Good afternoon, everybody. All right. So we're going to do a crash course on matrices and also on inequalities. The main of the inequality is going to be linear inequalities, linear programming. All right. You see these people here from morning, we're ready to start at 4, and they still have something to do at the time to start. People are serious. Anyway, guys, so we're going to try and run through the main things you need to know about matrices. So I did send a request in the group for persons to indicate what topic they want to go through today. A number of persons said matrices, a number of persons said inequalities. There was also a request for what we're going to be doing tomorrow. All right. And then based on the feedback, again, after tomorrow, I might have some sessions in the week. We already plan what we're doing next week. All right. So I think this is it. All right. So let's talk about matrices a bit before we actually get into questions. What are the main things to know about matrices? I'm not going to go from scratch and define a matrix and anything like that. The first thing we have to, hey, tell them over there to quiet for me, please. The first thing we're going to mention in matrices is the term order. The order of a matrix is referring to the size of the matrix. So order is another name for size. And the order or size of a matrix is given by describing or by stating the number of rows by the number of columns in the matrix. So the order of a matrix is rows by columns. So a matrix has rows and it has columns. Instead of by, sometimes I write it rows times columns. I spelled column wrong twice. So for example, if a matrix is a 3 by 2 matrix, it means it has 3 rows and 2 columns. So if I were to sketch out a matrix like this, it will have 3 rows of values and 2 columns of values. So the values, if I were to just put dots represent values now for this one, it will have 3 rows of values and 2 columns of values. So there you have 3 rows. So rows are the horizontal data, 2 columns. Columns are the vertical data. If I were to switch around this order and instead write it as a 2 by 3 matrix, then this now would have 2 rows and 3 columns. So in this case, you would have 2 rows of data and 3 columns of data. And so if you were to place dots to represent values, it will have 2 rows but 3 columns. So these dots representing data like numbers, values. So this is an example of a 3 by 2. That's a 2 by 3. Right? So this order thing is going to become important because when we start to multiply matrices, you have to understand when a question asks you what the resulting order of the multiplication would be. Then we're going to mention types of matrices. So that was order of matrices. Crashing through, types of matrices. What are some of the common types of matrices that we'll have to use? One is a row matrix. Because we're multiplying matrices, we're going to be multiplying rows by columns. So an example of a row matrix is one that has just one row alone. One row only. Like this, a row matrix, there's 2 values. If I put values in there, for example, 2 minus 5, 2 values in 1 row. It's an example of a row matrix. This would be a 1 by 2 matrix. has one row but two columns. Really has two columns. That could be a 1 by 2. Then we can have a column matrix. And we use column matrices a lot, especially in vectors and in transformation and so on. And a column matrix has one column only. So an example of a column matrix that we're going to be using a lot is, for example, a matrix like 3, -3, 4, for example. And this has 2 rows and just the 1 column. So a column matrix has just 1 column. So this will be a 2 by 1 matrix as an example. The other kind of matrix I want us to take note of is one that we call the identity matrix for multiplication. So there's an identity matrix for addition and there's an identity matrix for multiplication. Most questions are centered on the identity matrix for multiplication. The identity matrix. And at this level is a 2 by 2 matrix. And it is represented with the letter I, and it has a value 1, 0, 0, 1. That's the identity matrix for multiplication. We're going to talk a little bit more about this matrix when we get to multiplication of matrices. So some questions will give you this letter I, and you have to know that they're actually talking about this matrix. They will refer to this letter I in a question, and they're talking about that matrix. That's the identity matrix for multiplication of matrices, for multiplication. There's also an identity matrix for addition of matrices. That matrix is called the zero matrix. Let's just call it the zero matrix here. And 1 is in which we give it letter Z, and all the values in there is 0. 0, 0, 0, 0. I can't tell you how this one works from now. What it means is that any matrix you add to this, the result is the same, which kind of makes sense, right? You're not changing any of the values. Right? And if you add a matrix and it's inverse for addition, you're gonna get this identity matrix. So for example, if you add 1, 2, 3, 4, and you add it to the inverse of addition, which means that these values now change sign. So by adding that to -1, -2, -3, -4, then the result is that zero matrix, where all the values equal 0. You're not going to see a lot of calculation, a lot of questions with this. You're going to see a lot of questions with this one. So it becomes very relevant in a lot of cases. That's a zero matrix. Let's talk about the 2 by 2 matrix a lot. We're going to do a lot of work with 2 by 2 matrices. 2 by 2 matrix. Let's talk about it a little bit. So an example of a 2 by 2 matrix is, let's just put some values there. -1, 3, 5, 0. So this matrix, it has 2 rows and 2 columns. So these are the 2 rows. And I can write them out. The rows of this matrix are -1, 3 and 5, 0. I can actually pull them out. 2 rows. It also has 2 columns. So these are the rows of that matrix. It also has 2 columns. And the columns of this 2 by 2 matrix would be -1, 5 down here. And the other one would be 3, 0 down here. So this one is called the first row. And this one is called the second row. That's 2 rows. This one is called the first column. This one is called the second column. These are the terms that we're going to be using to reference these rows and these columns, especially when we start to multiply. So this is the first row, second row, first column, second column. Then we have the diagonals. The diagonals. This diagonal that runs from upper left to lower right is referred to the main diagonal, or they call it the primary diagonal, or some teachers call it the leading diagonal, and some say it's the first diagonal. Any word that means first is referring to that diagonal. So it has two diagonals. Again, we're going to be using these diagonals when we're doing our calculation. So we're going to say, for example, first diagonal, leading diagonal, main diagonal, primary diagonal. So let's talk about the diagonal. So the diagonal that is first, the main diagonal. Let's write it out. The main diagonal. And instead of main, you could maybe have the word first, primary, or you might have the word leading. These are some words that I use to refer to the diagonal that runs from upper left to lower right. -1, 0, this way. That diagonal. Then we have the other diagonal that runs this way. We're going to be doing calculations, and that will involve that diagonal as well. That diagonal is now the second one, referred to as the second one. It comes after this one. So if I were to make this a little bit smaller and just put it beside it, let's put a line down the middle to separate it here. Then we're talking about now the second diagonal and not the main one. So this diagonal is referred to as the second diagonal. This one now, this one. So the second diagonal or they call it the second diagonal, the secondary diagonal, or the trailing diagonal. Or they might call it the following diagonal. So you have the leading and you have the following. The primary, you have the secondary, and the first and the second. So the following diagonal. And that diagonal now is the 1, 3, 5 down here. So those are all terms that we're going to be using on a 2x2 matrix. The rows, columns, the diagonals. We're going to be using them when we're calculating, for example, multiplying them. We're going to be talking about the rows and the columns of the matrices. We're also going to be talking about the diagonals, especially when we're calculating determinant and if we want to know if the matrix is single or not. All right? These are some terms that we're going to be using. All right. So that's the main thing I want to talk about to begin with, right? This is all revision. This is stuff that you should all know already. Then let's talk about some of the operations that you would do with matrices. Like, for example, you can add and you can subtract matrices. But the first thing, to add and subtract, they must be of the same order. The matrices that you're adding or subtracting must be of the same order or the same size. So you can only add, and you can only subtract two matrices that are the same size, same order. So for example, if I have a matrix 2, 3, 5, 1 minus 1 minus 2, 0, I can add that to another matrix of the same size. What is this matrix? This is at 2, this is at 2 by 3. See, it has 2 rows and it has 3 columns. I can only add this matrix to another matrix of the same size. So another 2 by 3 matrix. So for example, I'm adding that to -1, 4, 0, 2, 4, -1. I can add those 2 matrices, make it a little smaller. And the resulting matrix is going to be the same size as well. So the resulting matrix is obtained simply by adding the corresponding values. After subtraction, you're subtracting the corresponding values. So for example, you add this one and this one. That's 2 and -1 becomes 1, because 2 minus 1 is 1. You add this one and this one. That's a 3 and 4 is 7. So you have 7 right here. You can add this one and this one. That 5 and 0 is 5. You can add this one and this one. That's 3. Then this one and this one, that's -2 and 4. Same as 4 minus 2 is 2. This one and this one, 0 and -1 is just -1. If you are subtracting, it's the same thing. There's one thing maybe I forgot to mention up here. We spoke about the 2 by 2 matrix, which is something that that's also very important. We're going to be multiplying the matrices. It is the position of each value. The position of each value. I'm not going to use this matrix and put the position beside them in red. So R is going to mean row, and C is going to mean column. So remember, you know, this is your first row, row 1. This is your second row, row 2. This is your first column, column 1. This is your second column, column 2. Column 2. So each element can be identified by the position that it is in the matrix. Let me show what I mean now. Let me leave those, take off these lines. Sorry. So this value, for example, it is in the intersection of row 1 and column 1. So we can refer to this matrix as the R1C1 matrix. Value. R1C1. This one, it is in the first row, but it is in the second column. So we can refer to this value as the R1C2 value. Then this value, it is in the second row, but the first column. And so we can refer to this value, identify it as the R2C1 value. And then this last value, it is positioned in the second row and the second column. And so we can refer to this value as the R2C2 value. Row 2, column 2. And notice that each of them is unique. None is repeated. Each of them is unique. So you can identify the element by stating the row and the column of its position to locate which element you're talking about. Again, this is going to become relevant when we start to multiply the matrices. All right, but let's get back down here now. We're talking about adding. If you take the same 2 matrices and decide to subtract them, just to extend the example. Let's copy this, paste it here. We're now going to subtract them. So instead of adding between here, we're now going to subtract. So let's change that to a minus. And so these results are going to be different. So let me take these out. So those results are going to be different. Again, it is possible, because that's a 2 by 3 and that's a 2 by 3. You're able to add them and subtract them. And again, you just add and subtract the corresponding values. So for example, this will be 2 minus a -1. This minus here becomes a plus. There's really 2 plus 1. That value there is going to be 3. The result here will be 3. Then to be this 3 minus this 4. 3 minus 4 is -1. So here will be -1, that value. Then to be 5 minus 0, corresponding value. 5 minus 0 is just 5. Then it is 1 minus 2. 1 minus 2 is negative 1 right here. Then it is minus 2 minus 4. Minus 2 minus 4 becomes a negative 6. Okay, minus 2 and minus 4 more, you get a negative 6. So this will be negative 6. Then it is 0 minus a negative 1. Again, this minus becomes a plus. So it becomes 0 plus 1 really, which is 1. This value will be 1. If you're subtracting the matrices. We're not taking anything for granted, you know, going through the most basic things. So far, so good. Everything so far easy. Yeah. Let's get to multiplication now. So we add, subtract, now we're going to multiply. So multiplication of matrices is a big thing on CSEC. Multiplication of matrices. What are some of the things to know about multiplying matrices? First, you can multiply it by a value, by a scalar value. When you multiply a matrix by a scalar value, you multiply each value in the matrix by that scalar value. So for example, you can have 2 times the matrix. 2 times the matrix, 1, 3, minus 4, 5. The result is obtained now by multiplying each of these values in the matrix by the 2. And so you will get 2, 6, minus 8, 10. That's multiplying a matrix by a value. You can also factorize a matrix, which is another form of multiplying. Because if I factorize a 2, for example, so for example, if I have the matrix, in other words, I can reverse this multiplication. Let's put it that way. I factorize it. Just as I factorize with the 2 to get this, I can just as I multiply the 2 to get that, I can factorize to get back that. So for example, if I have a matrix with a common factor like 3, 15, 12, minus 18, that matrix, each of these values is a multiple of 3. So I can factorize 3 from it and get this divided by the 3 is 1, this divided by the 3 is 5, this divided by the 3 is 4, this divided by the 3 is negative 6. So yes, I can factorize a matrix like that as well. Something that I've seen in a question some years ago is they gave a question with the matrix 2, 0, 0, 2 in some calculation. And all this matrix was a multiple of the identity matrix. So this matrix, if you factorize it 2, it was 2 times 1, 0, 0, 1. And that's the identity matrix. And if students recognize that time that this was just a multiple of this identity matrix, the question would have been much easier to do, much more easily done than it was by a number of students, by recognizing that this was just a multiple of the identity matrix. So sometimes it is useful to be able to go and factorize the matrix like that. All right? There are questions when that becomes relevant. All right. So that's multiplying by a scalar value. All right. We're gonna have this. We're gonna have the frequent occasion where our factor out here is actually 1 over a number. That's what we calculate in the inverse matrix. For example, 1 over 2. I multiply 1 over 2 by, for example, the matrix 3 minus 1, 4, 0. In this case, you can divide each of these values by the 2, or you multiply each of them by a half. But to multiply by a half is to divide by 2. So if you divide this by the 2, it becomes 1.5. I can put 3 over 2. If you divide this by the 2, it becomes negative 0.5 or negative 1 over 2. If you divide this by the 2, it becomes 2. 4 divided by 2 is 2. And then 0 divided by 2 is 0. So oftentimes, a lot of questions, we're going to encounter this, with this being the determinant under here. So we'll start to calculate inverse. We're going to have this situation as well. So far, I'm not sure nobody in this room anything strange. Good. Then now we come to the whole business of multiplying a matrix by another matrix. And this is where we start to step up the ante now. How do we multiply a matrix by another matrix? Firstly, the multiplication or the order of the matrices must be conformable. The matrices must be conformable for multiplication. So see here, multiplying by another matrix. In other words, to multiply two matrices. Let's try to multiply two matrices. One main thing, they have to be conformable for multiplication. And that's a word you have to be familiar with. In other words, for the multiplication to be possible, they must be conformable. This is the key word that CSEC will set the questions. They have to be conformable. Now, what do I mean by conformable? They are conformable. So let's say we multiply two matrices, right? Let's say I'm trying to multiply two matrices. A matrix multiplied by a B matrix. And when you multiply matrices, you don't have to put any symbol between them. It's understood that you're actually multiplying them. So let's say I'm trying to multiply two matrices, a matrix A times a matrix B. For this multiplication to be possible, this is what everybody must remember and know. The number of columns in the first one, which is A, must be equal to the number of rows in the second one. You must remember that. That's what conformable means. It means that the number of columns, in the first matrix, this time is A. Number of columns in A must be equal to the number of rows in the second matrix, which in this case is B. The number of columns in the first matrix must match the number of rows in the second matrix for the multiplication to be possible. Conformable is when it is possible. If they are conformable, then the multiplication is possible. So for the multiplication to be possible, the number of columns in the first matrix must be equal to the number of rows in the second matrix. So let's put up a couple of examples now. So let's say my matrix A, the first one, let's just give it an example. Let's say the first one is let's make it a 2 by 2. And the second one, let's make it a 3 by 2. 3 by 2. So that's a 2 by 2 matrix. Let's write it here. So in this case, we're trying to multiply a 2 by 2 matrix. That's the first one. I'm trying to multiply that with the second one, which is a 3 by 2. 3 by 2. So this is our 3 by 2. I'm trying to multiply them. Right now, the number of columns in this first one is this 2 right here. Use the purple. That's the number of columns in this first matrix is 2. The number of rows in the second matrix is 3. Right now, they are not equal. Not equal. The number of columns in the first matrix right now is not equal to the number of rows in the second matrix. So because that is the case, this multiplication is not possible. Cannot be done. They are not conformable for multiplication. It is not possible to multiply these. And CSEC will ask a question like this. Why is it that these two matrices cannot be multiplied? Just say these dots are any number, values, right? The dots are just putting dots right now to represent numbers like 1 and 2 and 10 and negative 3 and so on. Why is this multiplication not possible? Because they are not conformable. Because the number of columns in the first one is not equal to the number of rows in the second one. Simple as that. So this multiplication cannot be done. It's not possible. If I were to take the two same matrices and reverse the order and put this one now in front and set it up instead like this and put the 3 by 2 in front now, see? 3 rows of values, 2 columns of values. And I'm multiplying that now by the 2 by 2 that I had before. 2 rows and 2 columns. I would now be multiplying, pay attention now, I would now be multiplying. This is that 3 rows by 2 columns. Remember, I always state the number of rows first. Rows by columns. So this will be a 3 by 2 matrix that I'm trying to multiply with a 2 by 2 matrix. Now, in this case, the number of columns in the first matrix is now 2. And the number of columns in the second matrix is also 2. So now these two are equal. And so because the number of columns in the first matrix is now equal to the number of rows in the second matrix. When you're saying the order, it is a row by the column. Number of rows by the number of columns. So this matrix, for example, it has 3 rows. Rows are the horizontal data. 3 rows of horizontal data. And it has 2 columns. 2 vertical data. That's 2 columns. So it's a 3 by 2 matrix. So the number of columns right now in the first matrix is 2. Number of rows in the second matrix is also 2. They are equal, and therefore this multiplication is possible. It is possible to follow through. It is possible now. It's not spelled right. Possible not spelled with an A. Huh? How it's spelled? A-R-I. No. Mathematician. No. Huh? All right, thanks. Just so right a while ago. Anyway, let's continue. So this one now is possible. And when it is possible, we say that it is conformable. Conformable. It's now conformable for multiplication. You get me? So it can be multiplied. Now another thing you have to know is now what would be the resulting matrix. What's going to be the resulting matrix after we multiply these? The resulting matrix will have the same number of rows of the first one by the same number of columns of the second one. So when the multiplication is possible, the resulting matrix is going to have the same number of rows as the first one, the same number of columns of as the second one. So this 2 is going to multiply and give us a matrix that is of that order, 3 by 2. That is my 2 one. Mute the mic, please. right? So the resulting matrix is going to take the same number of rows as the first one and the same number of columns as the second one. So it's going to end up being a 3 by 2 matrix. The resulting matrix is going to be a 3 by 2 because the first matrix has 3, the second matrix has 3 rows, sorry, and the second one has 2 columns. So remember, the resulting matrix will take the same number of rows as the first one and the same number of columns as the second one. So if I were to draw the resulting matrix, because it is now possible, if I were to draw the resulting matrix, it's going to have 3 rows and 2 columns. 3 rows and 2 columns. So my resulting matrix is going to be a matrix like that. 3 rows, 2 columns. That's the first hurdle we need to clear in multiplication, whether the multiplication is possible or not. So that's the first thing CSEC like to test about multiplication. Separate and apart from asking you to multiply the matrices, they like to test your knowledge of whether or not 2 matrices can be multiplied or not, whether the multiplication is possible or not. All right? Then now, the next thing they're gonna test is the non-commutative nature of matrices, whether the matrices is commutative or not. And generally speaking, matrices multiplication is non-commutative. This is the next thing CSEC like to test. Now, what do we mean by commutative? Commutative refers to when you reverse the order of an operation and the result is the same. So for example, if you add 2 numbers, like 1 plus 2, and you switch around the order of this addition, it is 2 plus 1. The result is still 3, whether I add them in this order or that order. Similarly, if you multiply 2 numbers normally, like for example, 2 times 3, and you reverse the order of this multiplication of these 2 numbers, it is same as 3 times 2. The result is still 6. So addition of real numbers is commutative and multiplication of real numbers is commutative, because when you reverse the order, the result is the same. So these would be commutative. These operations, addition and multiplication, are commutative of real numbers. So you say that these are commutative operations. So that's what the word commutative is referring to. You reverse the order, what is the result? Matrices multiplication is non-commutative. So generally speaking, matrices multiplication is non-commutative. When you reverse the order, generally speaking, the result will be different. There are some unique circumstances when that rule goes out the window. Like for example, when the identity matrix is involved, like when you're multiplying a matrix and its inverse, you're going to get the identity matrix with whichever order you put them in. But generally speaking, it is non-commutative. And sometimes they ask you to do an example to show it. It is non-commutative. Now, we basically proved it a while ago up here, sir. Because when we had these 2 matrices in this order, multiplying them this way, this one as a first and this one as a second, it was not possible. When we take the same 2 matrices and reverse the order, it was possible and we could get a result. So where it could not work this order, this way, it could have worked this way. We can also show it with numbers. All right? But to show it with numbers, we have to go now and start actually doing the multiplication. Right? To go and do it with numbers. So let's go now and start actually multiplying the matrices. Are we ready for that yet? Yes, I think we're ready for that now. How do we multiply 2 matrices when they are conformable? And then, having multiplied them, we can reverse the order to show that the matrices multiplication is non-commutative. The result is going to be different when we reverse the order. So let's set up a simple example. Let's set up a simple example of two 2x2 matrices and look at how we multiply them. So we're going to look at how we multiply them now, and then we're going to extend it to show that when we reverse the order of the multiplication, the result is going to be different. So let's use some simple numbers. Let's use 1, 2, 3, 4. I'm going to multiply that with another 2x2 matrix. Let's multiply with another 2x2 matrix. That's going to be the most common multiplication, one of the most common multiplications. So let's use 0, minus 3, 2. Let's put minus 1 down here. Now let's put minus 1. Let's put minus 2 here. Let's put 3 there. Let's set it up like this. It doesn't really matter. Really important. Now this multiplication is possible. That's a 2x2 times another 2x2. Everything in sync. It is possible because the number of columns in the first and number of rows in the second is the same. The resulting matrix will have the same number of rows as the first one and the same number of columns as the second, which everything is 2. So this result is going to be a 2x2 matrix. All right. So when these two can be multiplied, we're going to get a 2x2. All right. So let's write the matrix that we're going to get. So let's say we'll multiply these two. We're going to end up getting a 2x2 matrix with 4 values. So I'm going to take the chance now of going through the process of multiplying these matrices one more time. All right. 4 values. All right. Let's go step by step. Now, when you're multiplying 2 matrices, you multiply the rows of the first matrix by the columns of the second matrix. That's how you multiply matrices. You multiply rows by columns. Multiply the row matrix by the columns of the second matrix. And you are multiplying the values that are in the same order. So, some other brothers are making a lot of noise. So for example, the element that is coming here, because this element right here is in row 1, that's the position of it, row 1, column 1. It means that to get this value, we're going to have to multiply this row 1 by this column 1. Because if we're trying to get the value that is in that position, you always take the rows from the first matrix when you're multiplying, and you always take the columns of the second matrix. When you're multiplying matrices, you multiply the rows of the first matrix by the columns of the second matrix. How you know which row to use and which column to use? By the position of the value that you're trying to get. So because this value is positioned in the first row and the first column, we use the first row from the first matrix and the first column of the second matrix. That's the first thing, knowing which row and which column you're going to multiply. The next thing now is how you know which values to multiply. It's simple. Just use the purple. You're going to multiply the first element in the row by the first element in the column. Multiply those two. Then you're going to go along the row and go down the column. And you're going to multiply the second element in the row by the second element in the column. Simple as that. And you're going to add the resulting values, add the products that you get. All right? So let's say it again. We're going to multiply this first row, this first row by this first column to get this value. How you multiply the row by the column? First element in the row times the first element in the column. See what that is? And then it is second element in the row by the second element in the column. And you're adding those values. So we say in this class, first element times first element, second element times second element. First element times first element, second element times second element. Some teachers say you multiply along the row and down the column, but it's the same thing. First element times first element. So the first element in the row times the first element in the column. Then second element in the row by the second element in the column, and you add up the values that they get. So let's work out this first one here now. The first one, we're going to put it here. So let me erase this. I'm going to put it there now. So it's the 1 times 0. That's first element times first element. 1 times 0 is 0. Then it's the second element and the second element. 2 times negative 2. 2 times negative 2 is negative 4. So this works out to negative 4. 0 minus 4 is negative 4. So the first value here is going to be a negative 4 in the result. So I can actually write what the final result is going to be here now. The first value here is going to be negative 4 because 0 minus 4 is negative 4. Then let's say the next value I want is this one right here. The one that is positioned right there. How do I know which row and which column to use to get that one? By the position that it is in. It is in the first row and the second column. That's where it is positioned. The first row and the second column. So we can say this is the row 1 C2 value. This value here that we're trying to get. So to get it, we use the first row in the first matrix, which is this one. I will use the second column of the second matrix, which is this one. So those are what we're multiplying. That first row by that second column. I multiply them the same way again. First element in the row is a different column. First element in the row by the first element in the column. And then second element in the row by the second element in the column. So we say first element by first element, second element times second element. First element times first element, second element times second element. Let's put in the values now. 1 times 3, that's first element times first element. And then 2 times negative 1, that's second element times second element. So it's 1 times 3 is 3. And 2 times minus 1 is negative 2, which is negative 2. So this works out to be 1. So I'm going to put the 1 right there in the final answer. 1 is the value going there. 3 minus 2 is 1. 2 down, 2 to go. So let's erase these now. So the next element that we're going to get is this one down here. This one right here. That element is positioned in the second row, but the first column, that's where it is positioned. The second row and the first column. So this element right now, it is row 2, C1. It is positioned in the second row, but the first column. So to get that value, we have to use this second row with this first column to get it, because of where it is positioned. I'll multiply the row by the column the same way again. First element in the row that we're using by the first element in the column. Then second element in the row by the second element in the column. So we say first element times first element, second element times second element. First element times first element, second element times second element. Let's put in the values now. So it's going to be 3 times 0. That's first element times first element. 3 times 0. That is 0. Then second element times second element. Second element in the row by the second element in the column. That is 4 times negative 2. 4 times negative 2 is a negative 8. So you're subtracting 8. So that is it. Then the 0 minus 8 is just minus 8. We put in minus 8 right there. So the final answer here is minus 8. And the final value there is minus 8. Then we have one last value to calculate. That's the one in this position here. This position. What is that position? This value is positioned in the second row and the second column. All right? So let's take these off. To get this value down here now, because it is in the second row, put row 2, C2. That's element, row 2, C2. Means that to get that value, we're going to multiply this second row by this second column. Or you multiply them again. Same thing. First element in the row times the first element in the column. And then second element in the row by the second element in the column. So we say first element times first element, second element times second element. First element times first element, second element times second element. Ready now? Let's do the calculation now. So it's 3 times 3. That's first element times first element. 3 times 3, that's a 9. And then 4 times negative 1. That's second element times second element. 4 times negative 1 is negative 4. So you're going to subtract 4 here. And then this 9 minus 4 is a 5. So the value right here in the final answer is 5. So this answer is 5. So this is a result of multiplying these two matrices. Let me take these off now. Now what I normally do to remind me that I'm using the rows of this matrix is put a line across here. What I normally do to remind me that I'm using the columns of this matrix, I normally put a line down here. So now I remember now that I'm using these two rows, these two columns. But when you multiply matrices, you have to take the rows of the first matrix and the columns of the second matrix. And you multiply first element in the row by the first element in the column, second element in the row by the second element in the column. And this is a third element, then it's third element in the row by the third element in the column. CSEC won't go past that. It won't give you anything more than 3 to multiply. So it's first element times first element, second element times second element, and if they extend it, it can be third element times third element. If it's a case where you're multiplying 3 values. All right? Everybody good so far? See some people online. Everybody online okay so far?
Yes, sir.
All right, good. Now, we're going to reverse the order of these two multiplication, these two matrices now. Just switch them around and show that the result of the multiplication is going to be different. And remember, if only one value is different, then it is different. All right? So let me turn these two matrices, just reverse the order of that multiplication and see what happens, just to prove that matrices multiplication, generally speaking, is non-commutative. So I'm going to copy them down here first. And I'm going to reverse the order. I'm going to put this one in front here. So the same two matrices, but I'm now going to multiply them in the reverse order. All right? So it is as if I call these matrices letters, like for example, if this matrix was A and this was B, like this matrix was A and this matrix was B, what I calculated here is the matrix AB, because I multiplied the first one by the second one. So this is the matrix AB. Now I've switched them around, so now I am multiplying the B1, this is now the B1, times the A1. So it is as if now I am trying to get the matrix BA. That's what I'm trying to get now, the matrix BA. All right? So let's show now that BA is going to be different. So if we follow the same process of how we multiply them, the result is going to be a big 2 by 2 matrix again with 4 values, because they're 2 by 2. All right, I'm back. But can you hear me again and can see the screen online?
Yes, sir.
Yes, sir. Dip in the, all right, in the internet. All right, good. So again, what we're gonna do, I need to change these, right? Because I'm now multiplying. This is now the first matrix. So I now have to use these two rows. So I'm gonna put a line across here to tell me that I'm using those two rows. And I have to use the columns from the second one now. I'm gonna put a line down here to indicate that I have to use those columns. So back again. Because this value here that I want, it is positioned in the first row and the first column. To get it, I have to multiply this first row by this first column. I multiply them the same way again. First element in the row by the first element in the column. Second element in the row by the second element in the column. First element times first element. Second element times second element. So in this case, the value would be 0 times 1 and 3 times 3. First element times first element. Second element times second element. 0 times 1, 3 times 3. The 0 times 1 is 0. And the 3 times 3 is 9. So if I were to write this now as the resulting matrix, then this value here is a 9. And you can already see that the matrices are different. This is the matrix BA now, you know, this one down here. This is the matrix BA. This one is BA. This one down here is BA. This one up here is AB. So the reverse, the order is reversed. Already you can see that the result is different. Because this first element in AB is different from this first element in BA. You really don't need to do any more to show that they are non-commutative enough. Because once one value is different, the matrices are different. You get me? So this means that AB is not equal to BA. It means that AB is not equal to BA. Why? Because matrices multiplication is non-commutative. Right? Non-commutative. And CSEC like to ask question about this. That they are non-commutative. All right? So I don't need to work out the remaining values, guys. Right? But if you work out the remaining values, some might come back to be the same and some might come back to be different. But that is it. So far, so good, everybody? Yes, sir. Online, everybody okay so far?
Yes, sir.
Yes, sir. Yes, sir.
All right. So next thing we're going to talk about now is inverse matrix and what inverse matrix can be used for. I'm going to eventually introduce the singular matrix. All right? Let's talk about inverse matrix now. Or the inverse of a matrix. And at this level, we're really talking about 2 by 2 matrices. They won't extend past 2 by 2 matrices at this level. So we're talking about the inverse of a 2 by 2 matrix. All right? So inverse. It doesn't matter at a higher level, you'll have to find inverse of larger matrices than 2 by 2. All right? So inverse matrix. All right. So it's quite simple. I can use some values, or sometimes we can use some letters to indicate it. If a matrix has the values A, B, C, and D, which most textbook will show it, then the inverse matrix, which is written m to the minus 1, just like inverse function or inverse anything, they put the minus 1 on it. The inverse matrix m to the minus 1 is equal to 1 over what we call the determinant of m. And the determinant can be seen as the thing that determines if the matrix has an inverse or not. The determinant determines if a matrix has an inverse or not. So put the determinant under here. I'm just going to write DET for determinant. Now let me write it out. Everybody in here know what the determinant is. The determinant of M. They multiply the determinant by what we call the adjoint of the matrix M. The adjoint matrix. The adjoint of M. This is going to give you the inverse matrix. So the question is, how do we calculate the determinant and how do we construct the adjoint? Simple. 1 over the determinant. What's the determinant? The determinant is the leading diagonal product. The leading diagonal product, meaning the product of the elements on the leading diagonal, that will be A times D. So you multiply these two values. The element on the first diagonal, remember we call this main, we call it leading, we call it primary, we call it main. So any one of those words that is used to describe this diagonal is acceptable. So the elements on that first diagonal, we multiply them. That will be AD. Then you subtract the product on the elements on the second diagonal. The elements on the second diagonal, you multiply them. That is B times C. BC. So this is the first diagonal product, the first product. And this is the second product, the second diagonal product. So the first diagonal product minus the second diagonal product, that gives you the determinant. Remember, the determinant determines if the matrix has an inverse or not. All right? So that's the first. We're going to discuss that afterwards when a matrix does not have an inverse. So the first diagonal product minus the second diagonal product. Then how do we construct the adjoint? The adjoint is constructed by interchanging the elements on the first diagonal. So these two values on the first diagonal, you interchange them. These are just steps that you must know. CSEC is not going to ask you to explain why you do it. I can tell you what the result of it is. But the adjoint is constructed by interchanging those first values on the first diagonal. So you basically switch these around. So this D, it is there, it's going to come here now. And this A that is starting that diagonal is going to come at the bottom of the diagonal here. So you interchange the elements on the first diagonal. Look at it. This is the first diagonal. You interchange them. So AD becomes DA on that first diagonal. Then the elements on the second diagonal, remember we're trying to form the adjoint. The elements on the second diagonal, you leave them where they are. You don't switch them around. You leave them where they are, but you change the sign. Meaning if it is positive, you change it to negative. If it is negative, you change it to positive. So this B will stay in the same place and become a minus B there. I'm going to put a negative B here. We're going to do it with numbers just now. And this C on the second diagonal, it stays where it is. And it's going to come back in the same place, but it's going to change sign and become a negative C. And this becomes your inverse matrix. This becomes the inverse matrix. All right? So, what is the significance of the adjoint? Let me tell you the significance of the adjoint. This matrix and the adjoint. When you multiply a matrix and its adjoint, you get what we call a diagonal matrix. You end up with a diagonal matrix. When you multiply a matrix and its adjoint, you get a diagonal matrix. What's a diagonal matrix? A diagonal matrix is a matrix where you only have non-zero value on the first diagonal. So if you multiply these two matrices right now, I'm going to end up with a matrix like this, with 0 here and 0 here. The value that's going to be in these two positions are actually the determinant. You're going to get the determinant right here and the determinant right here. When you multiply a matrix and it's adjoint, that's what you get. You get a matrix that has, we call it a diagonal matrix. The determinant is here. You get the determinant here and the determinant here of the matrix. So you multiply the matrix M and it's adjoint, you get a diagonal matrix where the determinant of M ends up in this position. But CSEC is not going to test that. I'm just telling you. All right? CSEC is not going to test that, but I'm just telling you. Then now we come to what is the significance of the matrix and its inverse. It is this. The matrix and its inverse. That's this one times this one. When you multiply a matrix and its inverse, the result is that identity matrix that we spoke about earlier. Just like when you multiply a number and its inverse, like 2 times half equal 1. 1 is the identity value in normal numbers, for multiplication, in real numbers, 1. Right? So 1 and identity matrix kind of similar in a kind of way. And here you're multiplying 2 and its inverse, you get the identity value for multiplication of numbers. But this is it. When you multiply a matrix and its inverse, you're going to get the identity matrix. Now, CSEC will ask you to prove this, to use it, to do all kind of things with this all the time in questions. And they will give you this letter I. This letter I. And you have to know that that letter really is the matrix 1, 0, 0, 1. Once you multiply a matrix and its inverse, that's what you're going to get. So the product of a matrix and its inverse is the identity matrix. If a product of two matrices is the identity matrix, then they are inverse of each other. Put it what I mean. If B times A or A times B or P times Q equals 1, 0, 0, 1. If P times Q equals that, it means that P is equal to Q to the minus 1. It means that these two matrices are inverses of each other. And it can also say that Q is equal to P to the minus 1. If the product of two matrices equal identity matrix, then they are inverses of each other. These two are inverses of each other. P is the inverse of Q, and Q is the inverse of P. Once the product of them is the identity matrix. That's the relationship between a matrix and its inverse. And CSEC will test your knowledge of that. All right? But let's do this. Let's do this with some numbers now. The inverse matrix. Let's calculate it with some numbers now. Just to show it, right? I want to talk about the determinant afterwards and what it indicates. So let's say I have a matrix. Let's say the same letter. I want to use some numbers. M equals 1 minus 3, 5. 1 minus 3, 5, and let's put 4 right here. Just making up a matrix for illustration. I'm going to calculate m to the minus 1, the inverse of this matrix. Remember, m to the minus 1 is the inverse. We're talking about the inverse. It is equal to 1 over the determinant of m multiplied by the adjoint of the matrix m. Now, the adjoint of matrix m, they put a D on it. That's a symbol for the adjoint. I remember what I said about the adjoint is that when you multiply the matrix and its adjoint, you get in a diagonal matrix. That is what the D is for, diagonal. You get in a diagonal matrix, as I showed you a while ago. That's why they use a D as a symbol for the adjoint. All right? So I'm going to do this calculation now with this matrix up here. So this becomes equal to 1 over the determinant. Remember, the determinant is the first diagonal product. That's a 1 times 4, which is 4. Minus, you have to put that minus. Careful now. The second diagonal product is 5 times negative 3. 5 times negative 3 is a negative 15. So you're subtracting a negative 15. This minus minus becomes a plus. So it's this product first, which is 1 times 4, minus this product is a 5 times negative 3, negative 15. You have to recognize now that this minus minus becomes a plus. Then we're going to multiply that now by the adjoint of the matrix M. What we will do is switch around these two elements on the first diagonal. Switch them around. So the 4 goes here and the 1 goes there. You switch them around. Then you leave these two on the second diagonal where they are and you change the sign. So this negative 3 comes back in the same position as a positive 3. And this positive 5 comes back in the same position as a negative 5. And that is it. And then we have to recognize that this under here really is 19. So this under here really is 19. Because it is 4 plus 15 is 19. So the determinant is 19. Determinant is 19. So now it's a matter of dividing each of these 19 to get the inverse. All right. So this matrix would finally become equal to 4 over 19. 4 over 19. Let's write that better. 4 over 19. Then 3 over the 19. 3 over 19. Then negative 5 over 19. Negative 5 over 19. Then 1 over 19. 1 over 19. So this is the inverse matrix. And I'm telling you, right now, if you multiply this matrix and this matrix, if you multiply them, you're going to get the matrix. 1, 0, 0, 1. If you multiply them. Yes? Yes? That's how you calculate the inverse of a matrix. All right? Now let's segue into talking about the singular matrix now, which is a common thing that you have to know about it. Common on CSEC. Information about the singular matrix. Knowledge of the singular matrix. A singular matrix. Now, what is a singular matrix? A singular matrix is single, like it lonely, it don't have no inverse. That's the first thing about this singular matrix. It has no inverse. It has no inverse. A singular matrix has no inverse. Why? Why is it that a singular matrix has no inverse? Because the determinant is equal to 0. Because the determinant is equal to 0. That is why it has no inverse. Now, why is that so? Because remember, in calculating the inverse, you do 1 over the determinant. Another way of writing the determinant, guys, is like this. Like a modulus. They put 2 lines on either side of the M to also mean the determinant. So this is another way of writing the determinant of M. So remember, to calculate inverse, we're doing 1 over the determinant multiplied by the adjoint matrix, The problem is that if this under here becomes a 0, if the determinant is 0, then you'll be doing 1 over 0 times the adjoint. This can't work out. You cannot divide by 0. To divide by 0 is an undefined quantity. The calculator cannot give a value for that. This is what we call an undefined situation. It cannot divide by 0. If you try to do it with a calculator, 1 over the 0, the determinant is 0. You cannot divide by 0. So if you use a calculator, it's going to give you some kind of error message. You put 1 divided by 0. See? 1 over 0. So you get a division message. See? Division by 0 is not possible. Every kind of calculator is going to give you something, a different error message. So you cannot try it if you want. So that is when, so because you cannot work out this 1 over 0, it means that the inverse matrix cannot be worked out. There's no inverse. And so a matrix is singular when the determinant is 0 and it's not going to have an inverse. And it's something that you must all know. So, an example of a singular matrix is, for example, 3, 4, 2, 6. Now I don't say 3, 4, 2, 6. What I did, I caused the diagonal products to be equal. So that diagonal product right here so is 12. And this diagonal product right here so is also 12. So when you subtract them, I get in 0. Because 12 minus 12 is 0. So I can tell you that that's a singular matrix. So we can then say the matrix is singular when the two diagonals equal, don't it? That's all? Because the two diagonals equal, when you subtract them, you're going to get 0. Right? So that's another thing we can say. When the matrix is singular, the diagonal products are equal. The diagonal products are equal. That's another thing we say. It has no inverse. And the diagonal products are equal. Diagonal products are equal for a singular matrix, because when you subtract them, you're gonna get 0. All right. So when the diagonal products are equal, the matrix is gonna be singular. Because when you subtract them, the determinant is gonna become 0. When you work them out, when you work out the determinant, you have to subtract the products. It's gonna become equal to 0. All right. So this is an example of a singular matrix. So this one is singular because if you work out the determinant here, the determinant of this matrix, call it M again. The determinant of M will be this product, which is 3 times 4, minus this product, which is 6 times 2. This is 12 minus 12, which is equal to 0. That's a singular matrix. Now the question can also talk about a non-singular matrix. A non-singular matrix. So it is as it said, non-singular. So if it's a non-singular matrix, it means that it is not singular. And if it is not singular, it means that it has an inverse. So a non-singular matrix, two things, has an inverse. Why? Because the determinant is now not equal to 0. So a question can say, show that a matrix is non-singular. To show that it is non-singular, you have to show that the determinant is not 0. That's all you have to do. So for example, if I write a matrix, a random matrix, 3, 2 again, but this time I'm going to put 3, 4 again. But this time I'm going to put minus 2, 6. Make it non-singular. Same value, but I put this as a minus. Let's call this matrix M again. M equals that. And I say, show that this is non-singular. Show that M is non-singular. To show that this is non-singular, you have to show that the determinant is not 0. Any value other than 0, the determinant can be. So to show that it is non-singular, you just have to calculate the determinant of M. Now, I keep writing this, but if you like, you can put this instead. This and this is the same thing, determinant of M. Whichever one you use. It's going to be equal to this product, which is 3 times 4, is 12. Minus this product, 6 times negative 2, that's a negative 12. So you're subtracting now a negative 12. You can put this in a bracket if you like, or you can leave it. Don't make a difference. This minus becomes a plus. So this actually works out to be 24. 24 is not equal to 0. 24 is not 0. Therefore, this matrix is non-singular. That is how you prove that it is non-singular, by showing that the determinant is not 0. That's what you do. Means that it is non-singular because the determinant is not equal to 0. You are able to calculate an inverse. But I got it so far?
Yes, sir.
What do you mean? I don't understand the question really. I don't understand the question. All right, so I will focus on the determinant itself. So if you want to determine if the matrix is singular or not, you look at the determinant itself. You're not looking at 1 over the determinant. You're looking at the determinant itself. That's the first thing you have to understand. We're talking about whether the matrix is single or not. We're not calculating inverse matrix now. The determinant tells you if the inverse exists or not. The determinant is 0, there's no inverse. Okay, you cannot divide by 0. Remember, in order to calculate the inverse, you have to divide by the determinant. You have to do 1 over the determinant. You cannot divide by 0. Any other value than 0 you get for the determinant. Whole number, fraction, negative, positive, no matter. Once you get a value that is not 0, an inverse exists. So maybe you're asking me this. Maybe you're asking me something like this. If your determinant, for example, is negative 2, and your matrix is negative 4, 3, 5, negative 6. That's what you're asking me? If you divide this by this, yes, the negative is going to cancel. You're doing normal maths. Yes, so that is normal maths. Negative 4 divided by negative 2, negative cancel, give you a positive 2. 3 divided by negative 2, that stays negative. So you get negative 1.5 or 3 over negative 2, same as negative 3 over 2. This divided by this, you're going to get negative 2.5 because 5 divided by 2 is 2.5 and it's negative. So you either get negative 2.5 or you get negative 5 over 2. Negative 5 over 2, or if you want to put 5 over negative 2, same thing. 5 over negative 2. All mean the same thing. And then it's negative 6 divided by 2, the negatives cancel. And then the 6 over 2 is 3. That is it. All right, yeah, man. So the negatives do what they normally do. If you divide negatives, 2 negatives, they cancel. If you multiply 2 negatives, they cancel. As before. Same thing happens in the matrices. All right. So people online, go before we move on. Just want to make sure.
Yes, sir.
All right. So we spoke about singular matrix and non-singular matrix. All right. I also spoke about the identity matrix. All right. So I'm going to talk now about equality of matrices. There are 2 types of equality of matrices. All right. I'm going to do a couple questions after this. All right. All right. Let's talk about equality of matrices. Solving equations, solving matrices equation. But we want to talk about equality type first, and then we want to talk about the one we have an unknown matrix and trying to solve for an unknown matrix. So, solving equations, solving in matrices, solving in matrices. Now, solving in mathematics means find the unknown value. That's what solving means. When you're finding unknown quantities, you're solving. Now, the first type of solving that we can do is we're finding a value within a matrix. So like, you know, all the values in a matrix except one. So like, for example, if our matrix set up like this, our matrix is equation set up like this, like it have an x here, 2, 5, 8, and you're adding another matrix, and the matrix you're adding here is 3. I'll just set up a simple example. 3. Simple example. 3, 4. Let's put a y right here and put 2 here. And they tell you that this matrix is equal to, let's say that this matrix is equal to make it be 7 there, so 6 there, so make this be 3, and it's going to be 10. So this matrices equation, we're adding these two matrices, and they tell you that it is equal to that. And you're asked to find the value of x and the value of y. Pretty simple. Equality of matrices. All right? That's solving for x and y. You're not solving for the whole matrix now. You're solving for values within the matrix, unknown values within the matrix. As the first kind of solving that we can do is matrices. So in this case, you set up, this is what we call equality of matrices. And what you know is that this x plus this 3 is equal to this 7. You know that. Right? You know that. So you set up that little equation where you say, okay, the x plus the 3 we know is equal to the 7. And if you subtract the 3 over here, you see that the x equals 4. You're done. You also know that based on this way, y is position, then this 5 and this y is equal to this 3. Right? These two add to give you this 3. So again, you set up that little equation where you say, okay, based on that, the 5 plus the y is equal to 3. You want to find the y, you take the 5 and subtract it over here. And so the y becomes 3 minus 5, so the y equals -2. So of that kind of equation, you can also get somewhere you're multiplying and there's a value in there. I'm going to give you an example with that. But I go so far with this one? But okay?
Yes,
Yeah.
All right. Now, if they give you 2 matrices to add and they tell you the result, then what you know about adding matrices? You know that when you add the corresponding values, or you know that to add these 2 matrices, you add the corresponding values. So it means that this x plus this 3, them add to give you 7. No, sir. Don't it? Because adding them, you know. So you write a little equation that says that the x plus 3 is equal to the 7 there. And then you also know that this y and this 5, they add to give you this 3. So see there, 5 plus the y is equal to the 3. So you get another little equation here to solve. And solve for the y that way, based on where the values are positioned. All right? So that's a simple equality of matrices. You just add the corresponding values. It can be subtracting as well, it can be multiplying. So let me do a multiplication one and show you how you would do it. Let me do a multiplication one and show you. I'm going to use the result that we have up from the first multiplication that we did at the top. Let me do it up here. Where is it? Because those we already have those values, I'm going to use this one. Right. So we're going to use this one. Let me copy all of this down and shift it around for you. And show you how you would approach this one, right? Let me show you what I mean now. So we did equality of matrices with addition a while ago. All right? We're going to do an example now where is a multiple of half. But in this case, it's not like you don't know. Undo. So we know that these two equal that. We know that from the get-go. So let me show you how the question would be given now. So this is how the question would maybe look. And in this case, they might have an unknown value right here, for example. Let's put a x right here, so. And let's put a y right here, so. But it's -1. So you get an equation like this to solve for the x and the y. Alright? So remember now, in this case, in this example, again, you don't know this x and you don't know this y. And the question asking you to find the value of x and find the value of y. But in this case, it's a product that you have, multiply. You're multiplying values now. So like I give you those two matrices and you know the result. So now you have to be smart. You have to use what you know about multiplication. So for example, you know that this row times this column is equal to this -4 right there. Isn't that so? You know that, right? Because this value is in the first row, first column. So to get it, you would have had to multiply this row by this column. So you know that. So that's what you have to go and use to find the x. So I would set up that multiplication like this. For example, this row, which is 1x, times the column, which is 0, 2. This row, which is the 1x up here. This column, which is a 0, not 2, 0, 2, 0, -2. 0, -2. That row times that column, we know it is equal to this 4 here, -4. We know that. This row times this column equals -4. So you can create an equation from this now. Because remember, first element times first element, second element times second element, going to give you that 4. So set up that equation. 1 times 0 is 0. X times -2 is -2x. See about -2 times x, that's -2x. Minus 2x. That you know is equal to this -4. And you're solving this now for the x. There's somebody in the class talking. Huh? Go outside, call, man. And then now, this becomes minus 2x equals 4 if you drop the 0. And you divide by this -2, you get x equals -2. And that will be the answer for the x. Simple as that. So that's what we also call an equality of matrices. You're not trying to find a whole matrix. But you know that this row times this column give you this value. So you set up that little equation here. And then you want to find the y. So that would involve the y. That this one over here is a product of this row. Well, I don't want to use the x, because x is an unknown. So I don't want to use the x. So let's use the 5. I don't want to use the x. Let's use this 5. This 5 is a product of this row and this column. You know that, don't it? Everybody know that this row times this column give you this 5 over here. So you set up another equation with them right beside it. Let's do it right here. So the row 3, 4 times the column 3y is equal to this 5. That's what it is now. Row 3, 4, see it here? Times the column 3y is equal to this 5 down here. So I've circled them. Because this time we're multiplying. And then you're going to expand out this now. Because remember, it's the same thing again. First element in the row by the first element in the column. Second element in the row by the second element in the column. Add up to 5. So it's 3 times 3 and 4 times y. See there, 3 times 3 is 9. Mute your mic, please, mute your mic. The 3 times 3 is 9. And the 4 times y is 4y. So you're adding 4y. And that result is 5. So you get that equation. So what you don't know, you subtract the 9 over here first. 5 minus 9 is -4. So you get 4y equals -4 first. And then divide by the 4. You divide by the 4. You get -1. So y equals -1. So those are your answers. That's another example of equality of matrices. But okay with that? Huh?
Yes, sir.
Scroll down here.
Yes, sir.
Yes, sir? Huh? Why? 4 divided by -2 and -2, my boss. Huh? Where? Oh, it's a -4. Oh, my mistake. All right, good. So I wrote the wrong thing here. All right, no problem. So I wrote the wrong thing here. So this is actually -4, -4. So it's going to be a 2. All right, thanks for that. Just as I wrote the wrong thing. So therefore I wrote the wrong thing. But the process is correct. All right, body good still?
Yes, sir.
Online,
Yes, sir.
body okay? All right, beautiful. So that's solving for values within the matrix. Now we're gonna talk about solving to find the whole matrix, like a matrices equation. So let me show you the background of solving for a matrix, a whole matrix. So let's say you have an equation, a matrices equation in this form. A matrix times x, I'm going to make x be my unknown, equals another matrix B. And I'm trying to find x. X is my unknown. So let me know this matrix, let me know this matrix. This is what I don't know. Simple matrices multiplication tells us that you're going to multiply the inverse of this matrix in front here. So x is going to be equal to the inverse of this matrix M times B. Now, how do I go from that to that? Now, we need to know this result, you know. But we need to understand what is happening behind the scenes that is causing us to go from this to this. Because sometimes CSEC asks a question that tests your knowledge of the process. What happened? So let me shift the result down a little bit and then inject what happened in between. So what happened really is that you want to move this M, okay? You want to leave X as the subject. And you know that a matrix times its inverse equals the identity matrix, or the inverse of a matrix times M is equal to the identity matrix. So to move this M, I need to multiply it by M to the -1. So that I multiply the left side by M to the -1, the inverse of M. But I also have to multiply the right side by M to the -1. But because matrices multiplication is non-commutative, I am multiplying M to the -1 by the left side. So I also have to multiply M to the -1 by the right side in the same order. So I have to put the M to the -1 in front. That is what the key thing is. So the M to the -1, undo. So the M to the -1 must also go in front here. See that? I'll use M to the -1 and multiply the left side, because this is the whole left side. And I use M to the -1 and multiply the right side, which is just the B. That's the first step. Then the M to the -1 times this M right here is going to give us the identity matrix, the I matrix. So this M times M to the -1 is I. So this time becomes I times X equals this M to the -1 times M remains, times B, sorry, remains. So this remains as M to the -1 times B. Remember, I know this is what became that. And then what I didn't tell you maybe earlier is that the identity matrix times any matrix gives you the same matrix. Because the identity matrix is just like the number 1. So see here, the I matrix times a matrix. A equals A. A matrix A times I matrix still equals A, because I is the identity matrix for multiplication. When you multiply a matrix times the I matrix, you get about the same matrix. So this calculation is going to come back to just X. Remember, the I matrix is a 1, 0, 0, 1, and remember, the I matrix we're talking about is 1, 0, 0, 1. It's going to come back as the same matrix X. This I times X is just going to come back as this X right here. See it there, sir? And this M to the minus 1 times B is going to come back as M to the minus 1 times B. So these are the intermediate steps that are shown in red. But generally speaking, we know that if you have a matrix times an unknown matrix times an equals another matrix, then the unknown matrix, you put the inverse in front here. And most of the questions, this implies this, most of the questions that you'll see in CSEC with solving matrices equation and solving for an unknown matrix will be set up like this. But still, the possibility exists that your unknown could be the one in front, like this over here now. So let me show you now. Now, I'm telling you, if you look at the CSEC specimen paper, you will see the other one, the one that I'm going to set up now. Just that I'm not seeing it in any exam, but it is on the CSEC specimen paper. When the unknown now is in front, like this. So this time I'm going to write about the matrices now, but I'm going to write it this way. Pay attention now, guys. So what's coming at the exam? X times a matrix equals B. Notice I've switched these around. This time, the X is the unknown. Look at the difference now. It is very, very important. We're still going to use the inverse of this matrix now. But it has to come behind here. The same position that it is in. So in this case, the X matrix is going to be B times M to the minus 1. See that? It is second on this side. The inverse has to be second on the right side. When the M is first on the left side, the inverse is first on the right side where you transpose it. Pay attention to the details. An example of this situation is if you get something like this, for example. I want to show you this one first. Majority of the questions going to be about this one. Even when we do the past paper, the majority of the questions are going to be that one. Like even the simultaneous equations. The unknown is always going to be positioned right here. But just in case to give you this situation, I want to show you an example of how that can set up. So for example, you can get a matrix equation like this. Like a matrix equation set up like this. A, B, C, D, an unknown matrix. Times a known matrix. 1, 2, minus 3, 4. Just randomly. Equals another matrix. 0, 2, 5, 1. So that the unknown is here now in front. The unknown is in front. Let me shift this over. Now remember, guys, this is what I'm showing you. CSEC has not set any question with any of them set up like this. It is always set up like this one. But the setup of this type was on the CSEC syllabus and on the specimen paper. It means that it is possible on your exam. But once it is on the syllabus and once it's on the specimen paper, it can come in the exam. They have not set any yet in any exam since the syllabus, where the unknown is in front. Since the unknown is in front, the inverse has to go second. I'll put it this way. Since the matrix that you're transposing is in the second position, the inverse has to go in the second position. Remember, matrices multiplication is non-commutative. You have to multiply them in the correct order. So if I'm going to make A, B, C the subject, look what that's going to the A, B, C, D matrix is going to be equal to this remains in front, because the inverse is coming behind, coming second. 0, 2, 5, 1 times the inverse of this matrix. 1, 2, minus 3, 4. Let me put the minus 1 on it here. That's the inverse of this that is coming here. I would have to work out the inverse of this matrix right there. So to finish this, what will happen? I'm not going to have to work it out. I'm just showing you up to a point. The A, B, C, D would now be equal to this matrix in front, 0, 2, 5, 1. And then the inverse of this now will be 1 over the determinant. 1 over the determinant. Remember, now the determinant is this product, which is 1 times 4, which is 4, minus this product, which is minus 3 times 2, which is negative 6. So you're subtracting a negative 6. This minus becomes a plus. They multiply that by the adjoint of this matrix. Remember, now we're doing the inverse now. We are doing the inverse right here. Right? That's what we're doing, the inverse. We'll put it, we'll underline it. All of this is the inverse. This means that we're doing the inverse. This is the inverse. The inverse of this matrix that was here. It has to come second in the multiplication. And so we're working on the inverse right here now. What's the inverse? 1 over the determinant multiplied by the adjoint. How do we do the adjoint? Interchange these two values on the first diagonal. So the 4 goes here and the 1 goes there. Leave these 2 on the second diagonal where they are, change the sign. This 2 becomes a negative 2 and this 3 becomes a positive 3. This under here is just a 10 because this minus becomes a plus. It says 1 over 10, it can come to the front now because it's a multiplying constant. So this would reduce to 1 over 10, because this is 10, minus is a plus, times this times that. 0, 2, 5, 1 times 4 minus 2, 3, 1. And then you would multiply these two, get your single matrix, 1 over 10. The A, B, C, D equals that. And after I do that, now you divide each of these values by a 10 and get a final matrix. Let's put something in here. A value here. Let's just call it X, Y, Z, W. When you work this out, remember you're gonna get value here, value here, value here, value here. Now we multiply these two. We're not doing it. But they never ever set it. That's why I'm not doing it. And then when you get these values now, then the A will be equal to X, whatever that value is. The A will be equal to the X. The B will be equal to the Y. The C will be equal to the Z. And the D will be equal to the W. That is how that situation would have to be done. But the majority of questions is centered around this type. Majority of questions is centered around this type. All right. And this type is set up using simultaneous equations and a straightforward equations. I think I'm at the point now we can actually do some past papers. I'm going to end and solve for the X. So I just do a little quick thing on this one, just in case. All right, you can watch over the video. And remember this thing, if the unknown is in front, you have to transpose the inverse of the known second. If it is second on the left, the inverse must be second on the right. In this case here, what you know is first, the inverse must go in front. On the left side, what you know is in front, the inverse goes in front on the right side. That's a transposition. It's very important they put them in the correct order. All right? Students online, okay, I'm going to do a couple past papers now. I think I've gone through the basics. Yeah? Huh? No, the simultaneous equation is going to be set up like this one. This will always go like that for the two lines. But this one is when they give you a 2 by 2 times a 2 by 2 like this one. Huh? No, man. A 2 by 2 by times a 2 by 2. Remember, you cannot multiply a 2 by 1. You cannot multiply a 2 by 1 times a 2 by 2, you know. This can't multiply, you know. So I couldn't give you that. You understand me? But that can't multiply. That's non-committee. That's non-conformable. Because it should be a 2 by 1. It should be a 2 by 1 times a 2 by 2. This and this not equal, so this is not possible. So they can't give you this. So they have to give you a 2 by 2 times a 2 by 2 equal a 2 by 2, but the unknown is in front. If they were to give you one like that, which is why I doubt they're gonna give you one like that. I doubt it. All right. So I'm asking online, okay? I'm going to go to a couple questions now from past papers. Online, not hearing anybody.
Yes, sir.
Are you hearing me? Okay.
Yes, sir. Yes.
All right. All right.
Yes,
let's jump
sir.
to a couple past papers. All right. Let's jump to a couple past papers. Now I'm going to do July 22. I'm going to do 2023, January 2023, question 10. I'm doing recent exam papers. I'm going to take a short break and come back for inequalities and linear programming. All right, let's do this. All right, January 2023. There's one on there. January 2023, right here. Question 10A. Let's look at this one. January 2020 or 10A. We're in the wrong way. There you go. All right. Here's a question. This is January 2023, a very recent exam. Question 10A. Let's go. So this question gives us these three matrices. These are 2 by 2 matrices. This is a 3 by 2. 3 by 2. It has 2 columns, 3 rows and 2 columns. First question. Explain why the matrix product is not possible. This matrix product QS is not possible. That's the first question. Explain why this matrix product Q times S is not possible. Which two are they talking about? They're talking about this one times this one. Don't pray. Don't pray. You know it now, just keep in your head. Say it to yourself. I'm going to say it now. You say, yeah, I'm right. All right, good. So we have to realize this product you'll be seeking to multiply a 2 by 2 because Q is a 2 by 2 matrix. And this one, S, is a 3 by 2 matrix. So you'll be doing a 2. You have to write it and show them now. You'll be trying to do a 2 by 2 times a 3 by 2. Now, why is this not possible? Because the number of columns in the first matrix is 2, but the number of rows in the second matrix is 3. These are not equal. So this matrix, these matrices are not conformable for multiplication. I can simply say because the number of columns in Q, which is the first matrix, is not equal to the number of rows in S. That's the reason why it's not possible. They are not conformable. Huh? No, I prefer you to write because the word explain. See the word explain? You can put this on the paper now, but because I say explain, I want you to write it out. So I would write out the reason. If you want to use the word, they are not conformable and so on, no problem. But the specific reason is that the number of rows in Q is the first matrix. See here, number of columns, number of columns in the first matrix, which is Q, is not equal to the number of rows in the second matrix, which is S. And that is it. If you want to say they are not conformable, not conformable. But it's because them say explain, you can't just put not conformable in. They're looking for this thing. They're actually looking for this number of columns in the first, number of rows in the second. I think they're looking for this statement. That's why they have the word explain. That is why. But I go to that online.
Yes, sir.
Yes, sir.
All right, good. Next part now says state the order. Remember, order means size. We dealt with that earlier. State the order of the matrix product. Somebody have a question? No? Okay. State the order of the matrix product S times R. All they want is for us to state the order of the resulting matrix S times R. What is S times R? Remember, S now is a 3 by 2 matrix. Let's write it out. We are doing a 3 by 2. The S is a 3 by 2. We'll be doing a 3 by 2 matrix. And the R is a 2 by 2 matrix. See here? Mute your mic, please. Mute your mic. Mute your mic, please. A 2 by 2 matrix. We are now multiplying a 3 by 2 and a 2 by 2. This multiplication is possible. Why? Because the number of columns in the first and the number of rows in the second now equal. So we know that it is possible. The resulting matrix will take the number of rows of the first matrix by the number of columns for the second matrix. Those will form the resulting matrix. So the resulting matrix S times R is going to be a 3 from here by 2 from here. So this is the answer that I'm looking for. But I just did all of this to explain it. But if you know and just write this down, you'll be good to go. But the question said state. But I go to that before I move on. But okay?
Yes, sir.
Yes, sir.
All right, good. Next thing I want us to do is multiply Q times R. Q times R. That's these two that wants to multiply. Q and R. Let's write them down and then copy it down. I want us to multiply Q times R, which is the 2 minus 1, 4, 3 times the 1, 6 minus 5, 4. So they want us to multiply these two matrices now. Q times R. Let's slide it down here. All right, so this one is Q, this one is R. A 2 by 2 times a 2 by 2 is going to give us a 2 by 2. So I'm going to draw a big 2 by 2 and say this is going to be equal to a, let's draw a big 2 by 2 and put in the values now. And the 2 by 2 is going to have 4 values. I'm putting in the positions of the 4 values. Now remember, when you multiply matrices, you take the rows of the first matrix. I'm drawing a line across there to remind me that I'm using those 2 rows. And I'm putting a line down here to remind me that I'm using these 2 columns. All right, let me zoom it up. Let's go now. So remember, the row and the column that you use depends on the position of the value in the resulting matrix. So this first value here, it is in the first row and the first column. So to get that value, we have to multiply this first row by this second column. You always multiply the rows of the matrix, of the first matrix, by the column of the second matrix. Or you multiply them. First element in the row by the first element in the column. Second element in the row by the second element in the column. First element times first element. Second element times second element. First element times first element. Second element times second element. Let's go now. 2 times 1 minus 1 times minus 5. 2 times 1, minus 1 times minus 5. I'm taking my time with this first one. So the 2 times 1 is 2. And the minus 1 times minus 5 is positive 5. So you know the first value there is a 7. So we're going through the first value. Let's remove this again and start over. The next value that we want to find is this one here in red. What is its position? It's positioned in the first row, second column. So to get it, we're going to multiply this first row by this second column. We multiply them in the same order again. First element in the row by the first element in the column. Then second element in the row by the second element in the column. So we see first element times first element, second element times second element. First element times first element, second element times second element. Let's go now. First element times first element, second element times second element. It is 2 times 6 and minus 1 times 4. 2 times 6 minus 1 times 4. The 2 times 6 is a 12. The minus 1 times 4 is a negative 4. Now come to this value down here now. It is positioned in the second row and the first column. So let's take these off now. So to get this value here, because it is in the second row and the first column, we're going to multiply this second row by this first column. Multiply them the same way again. First element times first element, second element times second element. First element times first element, second element times second element. Ready now? It is 4 times 1 and 3 times minus 5. 4 times 1, 3 times minus 5. The 4 times 1 is 4. The 3 times minus 5 is negative 15. That is it. Then we'll come to the last value out here. It is positioned in the second row and the second column. So to get it, we're going to multiply this second row by this second column. Multiply them the same way again. First element times first element, second element times second element. First element times first element, second element times second element. Ready now? 4 times 6 and 3 times 12. 4 times 6, 3 times 12. 4 times 6 is 24. 3 times 4 is 12. And then once we have those values in place, we can now write the final answer. 2 and 5 is 7. 12 minus 4 is 8. 4 minus 15 is negative 11. 24 and 12 is 36. So that is the answer right there. I'll take these off. Body good at that? Body near good at that? I'm gonna master this. Online, body okay?
No good,
Yes,
sir.
Yes, sir.
Very good. Beautiful. All right, let's continue. What does they want us to do? All right. This question says, they give us this matrix A, and they tell us that the determinant is 5. So this will be a non-singular matrix. Because the determinant is not 0, this is non-singular. It has an inverse. They don't ask us that, I'm just telling you this for information. It has an inverse because the determinant is not 0. Remember, this is another way of writing the determinant. So they're telling us that the determinant is 5. So we're going to set up a little equation down here. Now, what will be the determinant? The determinant will be this product minus this product. It's all the negative signs. You have to be careful. So that was setting up the equation, determinant equals 5, and then solve. So what to be the determinant? What to be the determinant? It will be this product first, 4 times x, which is 4x, minus this product is -1 times -7. Negative times negative is positive, so you're actually subtracting 7. That's the determinant, you know. They tell us that it is equal to 5. That is it. That's the equation you're solving now for the x. Transpose the -7 and add it first. You're going to get 4x equals 12. You carry over the -7, it becomes a +7. 5 and 7 is 12. Then you're going to divide by this 4. It's like we're dividing both sides by 4. Our shortcut, we say the 4 over here is multiplying. We divide it under this side. Anyway, you want to look at it, the x is going to be 3. 4 times 3 is 12, so x is equal to 3. But okay with that, that finishes that matrices question. Let's jump and do another one. I'm going to finish this session about, now we start 4. I'm going to finish about 6:30. I'm good. Yes? Huh? Say that again? Oh, let me take this off. Let me take this off. Yeah, man. -7 times -1. No, you're subtracting. Subtract the other product. Other product is -7 times -1, giving you a +7 here. But this product minus, see the minus there? The second product is this 7 there. Good? That's why I said be careful with the negative signs. All right. But okay there? But good? Before we move on, let's do another one.
Yes, sir.
Let's do another recent exam. Let's do July 2021. July 2021. 2021 July. Right here. I want us to at least do one. We're solving an equation, simultaneous equation, right? For pause, and then we're gonna break and come back for inequalities and linear programming. All right, number 10A. All right, let's see this one. All right, so this one, not a lot in this one. Just to multiply these two matrices. I think I want to skip over this one a bit because I want to make sure. It's not a lot. I want to make sure. I want to say, all right, let's do it. I want to make sure that we're getting one of the ones we were solving the equation, right? I want to at least do one of those. All right, so this question wants us to multiply these two matrices. Remember, this is a 2 by 2. 2 by 2. This is a 2 by 2. This is a 2 rows by 3 columns. This is a 2 by 3. 2 by 3. What's going to be the result? It is possible, because remember now, these two equal, so it is possible. The result is going to take these two numbers. So the result is going to be a 2 by 3. If I set it up right, you know, the result is going to be a 2 by 3 matrix. You have to know what kind of matrix you're gonna get. All right. So let's write what we're gonna get. I'm just gonna work with this on the screen. So I'm gonna get a 2 by 3 matrix like this. It's gonna be equal to 2 rows and 3 columns. So 2 rows of values and 3 columns. Excuse me. So that's what we're gonna get as our answer. Remember now, you're taking still the rows of the first matrix and the columns of the second matrix. So using these 2 rows with these 3 columns. All right, let's go step by step now. So let's say you want this value first. Where is it positioned? First row, first column. So to get it, let's make this pen a little smaller. So to get it, we have to multiply this first row with this first column. Let's go a little bit quicker this time. Same thing again. First element times first element, second element times second element. First element times first element, second element times second element. 5 times 2 and 4 times 0. 5 times 2 is 10 and 4 times 0. 5 times 2 is 10 and 4 times 0 is 0. That's the first value. Second value right here now. It's positioned in the first row and the second column. So to get it, we're going to multiply this first row by this second column. Multiply the same way again. First element times first element, second element times second element. First element times first element, second element times second element. 5 times 1 and 4 times 3. 5 times 1 and 4 times 3. The 5 times 1 is 5. 4 times 3 is 12. That's the second value there. And the third value out here that we want is positioned in the first row and the third column. So to get that, we're going to be using this first row with the third column. Multiply them the same way again. First element times first element, second element times second element. First element times first element, second element times second element. 5 times negative 4, 4 times 6. 5 times negative 4 is negative 20. And 4 times 6 is 24. We'll shift this bracket over a bit. So far, so good, everybody? So far, so good?
Yes, sir.
Online?
Yes, sir.
Good. Good. All right. And this value here, now that we want, this one down here, it is positioned in the second row and the first column. So to get it, we have to multiply this second row with this first column. You multiply them the same way again. First element times first element, second element times second element. First element times first element, second element times second element. Ready now. Minus 3 times 2 and minus 2 times 0. The minus 3 times 2 is negative 6. The minus 2 times 0 is 0. All right. We'll come to the next pair. This next value here is positioned in the second row and the second column. So to get it, we're going to multiply this second row with this second column. Same way again. First element times first element, second element times second element. First element times first element, second element times second element. Minus 3 times 1 and minus 2 times 3. Minus 3 times 1 is negative 3. And minus 2 times 3 is negative 6. Let me shift this over a little bit to the left. This is right here. Then the last value that we want out here is positioned in the second row and the third column. So to get it, we are going to have to multiply this second row with this third column. I will do it the same way again. First element times first element, second element times second element. First element times first element, second element times second element. Minus 3 times minus 4 and minus 2 times 6. The minus 3 times minus 4 becomes a positive 12. And the minus 2 times 6 becomes a negative 12. So those are your values. Let's put the final answer now. So this right here is 10. See there? 10 and 0 is 10. 5 and 12 is 17 in the middle there. minus 20 and 24 is same as 24 minus 20. This is 4. Minus 6 and 0 right there is negative 6. Minus 3 and minus 6 is negative 9. 12 minus 12 is 0. And that is the answer. Nice and easy. Gotta go to that. Beautiful. Next question. State why the two matrices are conformal for multiplication. Simple. They are conformable because of this. We wrote it. Let me copy it down. They are conformable because of this. Right here. Let's copy this down. Why are they conformable? Because we have a situation where the number of columns in the first matrix is equal to the number of rows in the second matrix. That is why they are conformable. And you just have to state it. Just state it. State why. So you're going to state it. All right. What's the first matrix? They didn't give it a name. So I want to say first and second. All right. So they didn't give it a name. They'll call this A and B, for example, or they've used those letters. But we're going to use first and second this time. So I'm going to say the number of rows in the first matrix equals the number of columns in the second matrix. No, sorry. Number of columns in the first matrix equals the number of rows in the second matrix. Reason. Number of columns in the first matrix is equal to the number of rows in the second matrix. I can say that is 2. 12 equal 2. That's it. Next part here wants to determine the inverse of this matrix. Doesn't want the inverse. So remember, the inverse is 1 over the determinant multiplied by the adjoint. Just writing out what it is. We're just going to do this calculation now, right? It is equal to 1 over the determinant. What's the determinant? This product, which is 5 times negative 2 is negative 10, minus this product, which is 4 times negative 3, which is negative 12. Negative 12. So it's the first product minus the second product. And you multiply that by the adjoint matrix. I will do the adjoint again. Interchange these two elements on the first diagonal. Switch them around. So the negative 2 goes to the top and the 5 goes here. Then leave these two elements where they are on the second diagonal and change the sign. So this 4 stays where it is and becomes a negative 4. And this negative 3 stays where it is and becomes a positive 3. And we can work out what this is, because this is really equal to 2, you know. And the answer is really 2. Why is that 2? Because this really is a plus. It's really negative 10 plus 12 we have, which becomes a 2. So I'm just going to write a 2 right here. And so this actually equals to 2. This actually equals to 2. And so the final result then is obtained by dividing each of those values in the matrix by 2. So negative 2 divided by this 2 is negative 1. Negative 4 divided by 2 is negative 2. 3 divided by 2 is 1.5. I can put 3 over 2 if you want. And 5 divided by 2 is 2.5. And that becomes the inverse matrix. I think this question done on that paper. I want us to do at least an equation one. Let's look at June 2021. This was 2021. Let's do June 20. Let's look at 2016. There's one on 2016. There's also one on 2018. Let's do the 2018 first. Let's look at it. I want to at least do one we were solving an equation, at least that before break. January 2018. Let's see. January 2018. Can't do all of them, but want to at least get a good representation of the various ways the questions were set. I want to at least do a simultaneous equation one. At least 10C. Nah.
Sir, if you have time, can you look at the matrices for 2023?
Just the 2023 a while ago.
2022, my bad.
2022.
Yeah.
This is 2022. Since somebody asked me, which one? June or July? January or June?
June. May, June 2022.
2022 June. All right. 2022 June. What number is it?
10A.
The number?
10A.
10A. All right, good. 10A, 10A. This one is not really matrices. This one is really transformation. It's more transformation than a matrices. That's the thing with this one. Want to do it still? Is really transformation. We can do it still, no problem. Let's do it quickly. I want us to do still one we were solving an equation. This is really transformation. In fact, I did this question the other day where we did transformation. You want to go and look at that video? I did it last week.
Okay, sir, I will.
All right. We did this question where we did transformation last week in the marathon. So look for that video and you can find this question. We did it. All right.
Okay. Okay.
Yeah. All right. All right, if you WhatsApp me afterwards, I'll send you the solution for it. Send me a WhatsApp afterwards.
Thank you.
Okay, sir.
My WhatsApp number is 881.
Sir, I have your WhatsApp number.
Serious. Yeah, wait. All right, good. All right, so let's go back to the 2018 paper. I really want to focus strictly on the matrices. I want us to do at least one. Let me try 2016. I want us to do one where we're actually solving. All right, so July 2021. This is 2018. All right, let's run through this one. This is more the same, really. So it's asking us for a to the minus 1. Show that the identity matrix, when you multiply them, you get the identity matrix here. And all of them. This one asking us for a squared. The important thing with a squared, guys, is that you have to multiply the a matrix by itself. A squared means a times a. So I have to put a by itself. Minus 1, 0, 3, 2. Right? So a is this matrix. So a squared, you multiply this by itself. Minus 1, 0, 3, 2. So it should be minus 1, 0, 3, 2 times minus 1, 0, 3, 2. You have to go through the whole process again. Same thing. Multiply the rows of the first matrix by the columns of the second matrix. That's what the a squared stands for. Don't go squaring the values. All right. So I'm going to skip over this. But we just multiply two matrices like this. I'm just telling you that this is what you have to do for that one. All right. This one says, explain why this is not possible. Same thing again, the non-conformable. Right? AB is not possible because A times B up here would be a 2 by 2 times a 3 by 2. Not possible because these two numbers not equal. So the same thing they're asking from here to here. And then the a to the minus 1, we just did one a while ago. So again, that is easy. Just did one of that. And then for this now, after you get the a, to the -1 and get the A. You multiply them. When you multiply those two matrices, the A to the -1 that you calculate in the first part here times this same A right here, this I is actually the matrix 1, 0, 0, 1. That's what they're gonna get. When you multiply the inverse that you calculate here in this part, and multiply it by the matrix itself, you're gonna get this matrix. All right, that's what is happening here. So I'm rushing through because I want to do a different kind of question. So the I matrix really is 1, 0, 0, 1. That's what you're gonna get. All right, that will end that question. All right, and then this one is again is the order when you reverse them, right? Similar to the one that we did earlier. So let me skip over this. Let's look at 2016. I think there's a simultaneous equation on 2016. Let me see. I really want us to do a simultaneous before we go. B. 2016, 11B. Still not a simultaneous. We'll actually get this, but you see, the thing about it is that they gave us this. I can maybe put in what this could have been, right? I'm going to do this question, but you see this could have been an equation, a simultaneous equation. 4x plus y equals 1, and 3x plus 2y equals 2. So they could have given you an equation like that and asked you to solve it. And you would have gotten this matrices equation just the same. So we'll get to this, I'll explain that, right? Because I wanted to do a simultaneous equation before we go. But let me use this as an opportunity to show how we use the inverse in front of here to calculate xy. But let's go from the top for this one. And then we'll break after this and take a short break and start back with inequalities. Because this year we're going to do inequalities today. All right, right here. So this question says, determine the value of x for which this matrix is singular. Determine the value of x for which this matrix is singular. So remember, if it is singular, two things. It has no inverse. So instead of telling you that it is singular, it could have said to you, find the value of x for which it has no inverse. It would mean the same thing. Has no inverse. When it has no inverse, it's because the determinant is equal to 0. And it's simple. When the determinant is equal to 0, that's what I use for the purpose of the calculation. This product becomes equal to this product. When the determinant is 0, it means that the two diagonal products are the same. So it means that the 2 times x, that product, which is 2 times x, becomes equal to this product, which is 3 times 4. The two diagonal products become equal, 2 times 4. So this is 2 times x equals 12, and so the x must be 6. So if this diagonal is 12, then this diagonal also has to be 12 for it to be a singular matrix, for the determinant to be 0. In order for this product to be 12, the x has to be 6, and that is it. Nice and easy. But I go to that. We'll move on. All right. Here now they want us to multiply these two matrices, more of the same. Can we basically run through it again? And I give only 1 mark for that. Unbelievable. So basically multiplying again the 4, 1, 3, 2. I'm just going to run through this one quickly. Times the 1, 5, 2, 1. Remember, I take the rows of the first matrix. I multiply them with the columns of the second matrix. This becomes equal to 4 values. First value here is this row times this column that is red ink. So this value here is this row times this column. So it is 4 times 1 and 1 times 2. 4 times 1, 1 times 2. 4 times 1 is 4. 1 times 2 is 2. And this value here is first row, second column. So it's this row and this column. So that's going to be 4 times 5 and 1 times 1. 4 times 5 is 20 and 1 times 1 is 1. Then this value here is going to be this row times this column, which is 3 times 1 and 2 times 2. First element times first element and second element times second element. 3 times 1 is 3. 2 times 2 is 4. And this value out here, second row, second column, second row, second column. 3 times 5, 2 times 1. 3 times 5, 3 times 5 is 15. 2 times 1 is 2. So then we add the final result here, where this is 6, this is 21, this is 7, and this is 17. All right. We'll get down to here. It says, given that Pn is equal to that, determine whether matrix multiplication is commutative. Answer is no, because they say they're not equal. They're not equal. Remember, this is NP, you know. This one is NP. And they're now giving us Pn. They're not equal. They are not equal. So the answer is no. So it's like a giveaway question. I'm going to say, since NP is not equal to Pn, matrix multiplication is non-commutative. Non-commutative. That's it. And down here now, it says I'll calculate n to the minus 1. Just remind ourselves of what n is. N is this matrix. 4, 1, 3, 2. Let's write it down here. N is the matrix. 4, 1, 3, 2. I'm trying to do the inverse of it here. So n to the minus 1, remember, is 1 over the determinant of n times the adjoint of n, which becomes 1 over, what's the determinant? The determinant is this product, which is 4 times 2 is 8, minus this product, 1 times 3 is 3, multiplied by the adjoint matrix. So the adjoint, now we interchange these two on the first diagonal, switch them around, 2, 4, leave these two where they are, just change the sign. So this 1 becomes -1, same place. This 3 becomes -3, same place. This under here is just 5. So we can write this as 1 over 5 times 2 minus 1 minus 3, 4. And I'm doing this for a reason. Minus 3, 4. And you put the final matrix, which to divide each of these values by 5. So let me move this. Move this a bit. Push it over here. Let's write the answer down here. So divide each of those values now by the 5. So you're going to get 2/5 minus 1 over 5 minus 3 over 5 and 4 over 5. The thing though is that if you're going to use the inverse matrix, this is n to the minus 1. Right? So if we're going to use the inverse matrix to solve the equation, which is what we're going to do down here. You're not going to be working with this one with the fraction. The tip is, or the recommendation is that you use with this one, with the fraction outside, multiply the matrices with the integer values, and leave the fraction for last. So even though I'm going to be using the inverse matrix down here, I'm not going to be working with this one. I'm going to work with the inverse in that form. Let's do it. So what we have to recognize here now, it says hence. Hence means you have to use this result. We're given this equation to solve, and I was telling you, instead of giving you this equation to solve, they could have instead said, hence, solve this pair of simultaneous equations, which would have led to this equation anyway. All right, because let me just pull aside and do it now. If you have this pair of simultaneous equations, 4x plus y equals 1, and 3x plus 2y equals 2, and you're asked to form a matrices equation from that. First thing you want to do is ensure that the order of the values, x value followed by y value, x value followed by y value. That's very important. And then now it becomes a 2 by 2 matrix multiplied by the column matrix x and y, because they are in that order. And it becomes equal to a column matrix with these two values, 1, 2. And then the values that go in that matrix are the coefficients of the x and the y up here. Since there's no number on that y, that coefficient is actually a 1. They're never going to show it. It's actually a 1. And if this was, for example, a minus y, this was, for example, a minus y, then it would have been minus 1. So you'd have placed a minus 1 here. All right, but let's put back what it is. It's a plus y. So then the coefficients will be 4 and a 1 on the first line, 4, 1. 3 and a 2 on the second line. And this would have been your matrices equation. And then if you want to solve, remember you have to transpose this matrix now, the inverse of it in front there. The inverse goes in front. And so you really then would get that xy becomes the inverse of this in front here. 4, 1, 3, 2. Put the minus 1 on it in red so it becomes glaring. Times back this matrix 1, 2. So you really want the inverse of this matrix here. And that's how we use the inverse to solve the equation, which is the same thing that we're doing over here, because instead of giving us these two equations to solve using the inverse matrix, they went ahead and they gave us this instead, which is the same thing we would have gotten if they gave us the inverse matrix. And we still have to do this thing. All right. So I'm just telling you that they could have given us instead these two simultaneous equations to solve. But let's proceed and solve this now. So back to it. So since we now want to find xy, we must recognize that this really is the matrix n. The same n that we just inversed right here. And so we're going to transpose the inverse of n in front of this. So this xy as a subject would become n to the minus 1 times 1, 2. So you put the n that was here, it goes in front there. It must go in front. And then what is n to the minus 1? Again, we're not going to be using this. Use the one with the fraction outside. So I'm going to put it as 1 over 5 times that 2 minus 1 minus 3, 4. That's what it is. They multiply by this 1, 2 right here. Times 1, 2. That's what xy is equal to. So now we are tasked with multiplying these two matrices now. Leave the fraction out here for last. And oftentimes you end up getting multiples of the 10, multiples of the 5. All right? So let's multiply these now. So this becomes equal to 1 over 5 times a column matrix. When you multiply a 2 by 2 on a column matrix to get them back a column matrix with those two values. Let's get the red. So the same thing, you multiply the rows of the first matrix times the one column. This 1 over 5, we leave it here for last. So this first value is in the first row and the one column. So to get it, multiply this first row by this one column. Same thing again. First element times first element second element times second element, first element times first element, second element times second element, 2 times minus 1 and minus, 2 times 1 and minus 1 times 2. 2 times 1 is 2 and minus 1 times 2 is negative 2. That's going to become a 0. Then the value down here now, let's erase these. Right, so this value down here, not the one, or the second value, it is positioned in the second row and the one column. So multiplying this second row by the one column. I do them the same way again. First element times first element, second element times second element, first element times first element, second element times second element, minus 3 times 1 and 4 times 2. The minus 3 times 1 is negative 3. And the 4 times 2 is 8. So you're adding 8. And then when you simplify this, it's gonna become 1 over 5 times 0. 1 over 5 times 0. This becomes a 5. I divide each of these now by this 5. It works out to be 0, 1. So the xy is equal to that now. But don't leave this as your answer. You find the x and y. So if you say that the x equals 0 and the y equals this 1. All right, that is it. I'm going to take a short break and start back 7 o'clock. 15 minutes break. Starting back at 7 o'clock, I'm going to try and see if we can do some inequalities, and in particular linear programming. So we can get through that quickly. But the online okay?
Yes, sir.
Yes, sir. Yes, sir.
All right. So I'm going to take a short break. But I take a little short break, a little stretch leg. I'm going to start back. I'm going to do some linear inequalities, some simple inequalities first. And then we're going to jump and do some linear programming so we can understand these linear inequalities and in particular how we represent them on graphs. All right, so we can get in 1 or 2 questions before we are done. So starting back in 15 minutes. So let me put the timer on this. Maybe 15 minutes too long. We're starting back in 10 minutes. 15 minutes too long. Starting back in 10. 10 minutes. All right, everybody, we're back. Let's do this. But it's still there online?
Yes, sir.
Yes, sir.
All right. So we're gonna do some inequalities, and in particular on a graph. All right. But let's start with some simple inequalities first. Simple linear inequalities. Like for example, an inequality like 2 into x minus 6. This one even simpler one. Like for example, 2x minus 7 less than or equal to 3. Simple like that. Solving an inequality like this is the same process as if you are solving 2x minus 7 equals 3. The only difference with the inequality that we have to remember is that if there comes a point when solving this that we have to multiply or divide by a negative number, we have to reverse the inequality sign. So in fact, let me set up one that we have to do that. Let me set up one where we have to reverse the inequality sign. So let's say, let me give you one that can be done 2 ways. So let's say it's 8 minus x less than or equal to 5x plus 2. So solve means make x a subject. And there are 2 x terms in this one. There are one on the left and one on the right. You want to end up with x, you have the inequality sign whether greater than or less than, and you have the number over here. That's what you want. You want to make x a subject. So I can approach this 2 ways, which I'm going to do. I'm going to approach it one way when I group the x terms on the right side. I'm going to do it another way where I group the x terms on the left side. Mute the mic, please. Some of the mic is open. Mute the mic, please. Let's say we're doing it over here first. We're grouping the x terms on the left side. All right? So the first step is to take this 5x and bring it over here. Let me rewrite it. 8 minus x less than or equal to 5x plus 2. I'm going to do it first where I group the x terms on the left side. All right? And there's a very important step that everybody must take note of. So the first, leave a light. The first thing I'm going to do is take this 5x, leave the light. And put it on this side. And then this 8, I'm going to put it on that side. All right? So this minus x is going to remain here. This 5x, when I bring it over here, it's going to become negative 5x. The sign remains less than because I did not multiply or divide with a negative number. This 2 is there on that right side. This 8 goes over here and becomes a negative 8. That's what we have so far. This minus x and minus 5x becomes negative 6x. The sign stays as less than or equal to. This 2 minus 8 now is a negative 6. Now we're at the stage where we need to make x a subject. We're going to have to divide both sides by a negative 6 to get rid of this negative 6. Now, because we're dividing with a negative number, that's what you have to remember. Because you're dividing with a negative number, this inequality sign has to be reversed. And the key thing about these simple inequalities, remember, when you multiply or divide an inequality with a negative number, you have to reverse the sign. I said multiply or divide with a negative number. And I'm talking about add or subtract. Only when you multiply or divide with a negative number, you reverse the inequality sign. So if it's a less than, you reverse it to greater than. If it's a greater than, you reverse it to less than. So I'm going to write it here. But divide both sides by negative 6. And because I'm dividing with a negative number, I'll have to reverse that less than or greater than to sign. I have to reverse it and make it into a greater than. Then the result is going to be that this side divided by the negative 6 becomes an x. This sign is reversed to greater than or equal to. This negative 6 divided by negative 6 becomes a 1. And that is your solution right there. All right. Let's do the same inequality. We'll group the x terms on the right side this time. So I still have 8 minus x less than or equal to 5x plus 2. I'm going to solve it again, but this time I'm going to group the x terms over on the right side. So it means then that I'm going to take this negative x and bring it over here. It's going to become a positive x. I'm going to take this 2 and bring it over here. It's going to become a negative 2. So let's go. This 8 remains on this side. I'm not moving that. This 2 comes over here. It becomes a negative 2. Positive is positive. This sign stays less than. I did not multiply or divide with any negative number. So the sign stays as it is. This 5x is on the right side. Stays on the right side. This negative x comes over here. It becomes a positive x. So it becomes a positive x. Then I consolidate. 8 minus 2 is 6. Less than or equal to 5x and x is 6x. Then to leave x as a subject now, I need to divide both sides by 6. Turn it on. Huh? Yeah, I use the hotspot. I use the hotspot. All right, I'm back. All right, online, you there again?
Yes, sir.
All right, yes, good. So we're at the stage now again where we have to divide both sides by 6. This time we're dividing with a positive 6 right here to get x to be the subject. But to divide both sides by 6 to move this 6. All right, so I'm going to say it this time. Divide now by 6. Because I'm dividing with a positive 6, there's no need to reverse the sign. So I don't need to do this. Because I'm dividing with a positive number. So the sign stays the same. So when I divide this 6 by 6, it becomes 1. Less than or equal to divide 6x by 6, it becomes x. So I'm seeing this now. 1 is less than or equal to x, but it can be read from the right. It's the same as x is greater than or equal to 1. So the same solution. So we can say that is, i.e., x is greater than or equal to 1. So we have the same answer. And oftentimes they'll ask you to show a number line for this inequality. So if we show the inequality on a number line, so be a number line like this: 0, 1, 2, 3, 4, minus 1. X greater than or equal to 1. The critical value is 1. So I'm putting a circle on the 1 right here. That circle I'm putting on the 1, I'm going to shade it because the equal is a part of the inequality. So the equal is a part of the inequality. It means that 1 is also a value that 1. So I'm going to shade that circle on the 1 this time. And then greater than 1 means that I want values to the right. And that will be my number line, greater than or equal to 1. What is the difference? If instead, if for some reason this was just x greater than 1, when I put the circle on the 1, I would have to leave it unshaded to show that 1 is not a value that I want. I'm just putting it there as a boundary to start the region. Then for x greater than 1, I would have put arrow pointing to the right again, and this would be x greater than 1. Right? But the original question here are the equal on it. So I'm putting by the equal, and I'm shading back this circle to show that x equals 1 is a valid value for this inequality. But are you okay with that so far?
Yes, sir.
All right, let's put some sugar on one of them. So CSEC gave this one recently. They gave this one recently. 2 minus 4x divided by 3 less than 5 greater than negative 1. And I say we're to solve that. To solve that, you want to make x a subject right here. You want to transpose everything away from this x. Now, this inequality has 3 sides, a left side, a middle, and a right side. And you can do the same thing to all 3 sides. So what I'm going to do, I'm going to transpose everything away from the x. So the first thing I'm going to do is get rid of this 3 by multiplying all sides by 3. So that's my first step. Multiply through by 3. Because this 3 is dividing. To get rid of it, I need to multiply through by 3. So I'm multiplying all sides by 3. That's a positive 3. So there's no need to reverse these inequality signs. Multiply this by the 3 first, I get negative 3. The sign stays less than. Multiply inside here by the 3, it cancels this 3. And so I'm left with 2 minus 4x in there. Multiply this side by 3. This sign comes back first, the less than. Multiply this 5 by 3, I get 15. That's the second step. Next thing I need to do is move this 2. So to get rid of that 2, I need to subtract 2 from all sides. So let me write what I'm going to do. I'm going to subtract 2 from all sides. Again, I'm not multiplying or dividing by a negative number. So these inequality signs will stay as they are. When I subtract 2 from this side, it becomes a negative 5. Negative 3 and negative 2 is negative 5. Sign stays less than. The 2 gone from in here, I'm left with just this minus 4x. Minus 4x. Then I subtract 2 from here, I'm going to get 13. Subtract 2 from this side, less than 13. That's what I have so far. Next thing, I need to divide by this negative 4 to get x alone as in the middle. I want to leave x alone in the middle. I need to divide all sides by negative 4, negative 4, negative 4. And because I'm going to be divided with a negative number, these inequality signs will have to be reversed. So this is what we're going to do now. When I divide all sides by that negative 4, because I'm dividing with a negative number, I have to reverse that, reverse the signs, 2 less than signs. Stop talking, please. I'll go outside. Stop talking, I'll go outside. Not disturb me. When I talk, not disturb me. Once you can hear, no, that come through the thing. All right. So dividing this by negative 4, the negatives cancel. And that becomes a 5 over 4. Greater than. And leaves me with an x in the middle. So x is now in the middle. This sign again is reversed to greater than. Divide this by negative 4, I get negative 13 over 4. That's what we have. Now, I can actually turn this around because you really want to have a smaller value on the left side of the inequality. So I'm going to spin the whole thing around. Okay, I want to have the smallest value on the left and the largest value on the right. So you're reading it just as though you would read a number line from left to right. So this same inequality, if I spin it around, it will be negative 13 over 4 is less than x. See? The negative 13 over 4 is less than x. The x is greater than the negative 13 over 4. And the x is less than 5 over 4. So this x in the middle is now less than 5 over 4. You read it this way, you're going to get x less than 5 over 4. So the x is now less than 5 over 4. Why am I doing it that way? Because your numbers will be in this order on a number line. I'm now going to represent this inequality on a number line. Let's put the values into perspective. This negative 13 over 4 is negative 3 and a quarter. Negative 3 and a quarter. Less than x, less than. This 5 over 4 is 1 and a quarter. 1 and a quarter. I'm going to represent this now on a number line because the question for this one did say we were to state the integer values of x for the solutions. I'm going to represent it on a number line first. So this is it. I'm going to draw the number line here. Put 0 here, 1 here, 2, negative 1, negative 2, negative 3, put negative 4. Ready now. So first, 1 and a quarter. So 1 here now. This is 1 and a half. 1 and a quarter. We're going to be about here. This is 1 and a right here. 1 and a quarter. This line right here. The negative 3 and a quarter. So negative 3. This is negative 3 and a quarter is going to be this line right here. Negative 3 and a quarter is this line right here. So I'm going to put the circle on that value to start. I'm leaving it unshaded because this n has no equal on it, just a less than. I'm going to put the circle on this 1 and a quarter value at the end of my region. And then now I want the region between them. So I'm going to put an arrow joining these two circles for the region between them. And that will be the number line for this inequality. X less than 1 and a quarter greater than minus 3 and a quarter. That's the number line for that one. Online, everybody okay with that?
Yes, sir.
Yes,
All right.
Yes, sir. Yes,
Now
sir.
the question wants the integer values of x. If x are integer values, and it says to list the integer values of x. That's what this question said. List integers of x. What are integers? Integers are positive or negative whole numbers. The positive or negative whole numbers. So the whole numbers in the range here, these. These are the whole numbers within that range that x can be. So if you were to list them, it will be those values that I have circled. So integer values x would have been negative 3, negative 2, negative 1, 0, and 1. Those will be your integer values x. The largest integer value would be 1, and the smallest integer value would have been negative 3. So another thing they could have asked is, what is the largest integer value x? It will be this 1 up here. What is the smallest integer value x? It will be this negative 3 down here. Remember, integers are positive or negative whole numbers. All right? So that's another example. So I give you 2 examples of how a question can be set. Let me give you another example how they set these simple inequalities. Let's look at another example. And this one was from a June 2018 paper. What they did in this question is that they gave you 2 inequalities, but it was really connected to 1. So they gave us 3x solving a part B. So this was like a part A of the question, and this was like a part B to solve. Now you must realize that this part and this part is the same. So we can actually combine, you know, Internet troubles, guys. Internet worries. Unstable internet. Anyway, let's continue. Right. So what I was saying is that these are actually two connected inequalities because this and this is the same. So we could have taken this and put it over here. I will see that we have one inequality. So if I take this and copy it and paste it here, you will see that is really 2 in 1, or this is now combining the two. If I did that, so for to take this back off and write it instead as this, the 3x minus 1, the minus 11 on the right side here, the greater than 2 on the left side there. It's that these two inequalities are really connected to that. But the question is here, decide to give it as two separate inequalities. All right, have this one down here and solve that one, the same steps, the same as solving all of this together. It's going to be the same steps. All right, 11. All right, so for to solve all of this as one, so put the two and solve it. Then the same as I did before with the question, I'm transposing everything away. Add 1 to all sides. Add 1 to all sides to get rid of this 1. All right, and this side will become 3 less than or equal to 3x end up in the middle, less than this side will become 12. Then to get rid of this, you're going to divide 2 by 3. Divide by 3. Because I'm dividing with a positive number, there's no need to reverse the signs. So divide this by 3. 1. Divide this by 3, I get 4. And then the question asks for the number line for that. Number line 0, 1, 2, 3, 4, -1. You really want value between 1 and 4. So you're going to put a circle on the 1 for this limit value. And because of the equal here, we're going to shade it. I'm going to shade it because the 1 is on the equal is on the 1. We're going to put a circle on the 4 for this one, for this end of the region. We're going to leave it unshaded because the equal is not there. So leave this one unshaded. And here we don't want a region between them. So they put an arrow, put lines joining them like this. And this is the inequality for less than 4, or greater than or equal to 1. That is it. All right. And for this one, if you're listing integer values, you could not include the 4. So if x is an integer, you're listing integer values, integer x, you could include the 1, but you can't include the 4 because we say we're less than 4. And we have an unshaded circle on the 4 means that the 4 is not included. So that will be your integer value is x. The largest value will be 3, and the smallest value will be 1 if the x were integer values. All right, everybody okay with that? I think we're going to jump into the thing now. We're going to start looking at the linear inequalities right away. All right, let's look at the linear inequalities now. All right, let's start linear inequality with a simple example. Like, for example, y greater than 2x plus 1. What does this really mean on a graph? In particular on a graph, what does it really mean? Huh? No. It's not the same. It's not the same as this. Y equals 2x plus 1. That's a line. Y equals 2x plus 1. This is giving you points on the line. This is giving you points above the line. Because y is greater than 2x plus 1. That's the difference. All right? So let me show you now. For to make a sketch of it. Let's say we have this graph. I should really put on a graph paper, you know. Let me get a graph paper. See if I can find a graph paper. I'll put it on it for you so you can appreciate what I'm trying to show you. There's a graph paper on 2017. 2017. There's a graph paper there. The first thing we have to do is understand what something like this means graphically. Where it gone? Sure. There's a graph paper on this. I want to use it to illustrate the point I'm trying to make. This one. I could use this one, but anyway. So this. All right. All right, so let's go. I'm going to scale this up. I was going to scale this up. Each centimeter as 1, right? So we can draw that line and see some points. I just want to use this one example so if we can appreciate the inequality on a graph, what it really means, right? So if you're using 1 centimeter to 1, then this is going to be 2, 4, 6, 8, 10. This is going to be 2, 4, 6, 8, 10. So doing a graph, that's the x-axis down here. I'm going to put the y-axis up here. All right, x-axis and y-axis. So this is the x-axis. And this is the y-axis. Now, the first thing is that this inequality is associated with the line y equals 2x plus 1. It's associated with that line. So the first thing we're going to do, we're going to draw the line. When you see this inequality, which is just greater than, it means that you don't want the line. The line is not a part. You don't want points on the line because you want points greater. You want points where the y value are greater than this. We're going to draw the line first. And to show that we don't want points on the line, we're going to draw this line broken. To show that we don't want the line. If the inequality was instead y greater than or equal to, then we would draw this line solid to show that we want the line. All right? So let's draw this line first. And let me take off this equal again. We're going to draw this line first. And you draw that line the normal way. You can plot 2 points, or you can use 1 point and grade it. So for example, you know that this line crosses the y-axis at 1. That's the y-axis intercept. So I'm going to put down a point here, 1. See it here? Let's put down in blue. It crosses the y-axis down here at 1, right there. Right here. Then there's a gradient of 2. See here, the gradient is 2. Gradient is 2. So we can rise 2, run 1 to get to other points, right? We can rise 2. This gradient is 2, 2 over 1. So from here, we can rise 2, run 1. Or we can plot another point. For example, we can put in x equals, for example, to get another point, we can put in x equals, say, 4. If x equals 4 right here, the y value is going to become 9. Because 2 times 4 is 8. 8 and 1 is 9. So this graph passes through a point 4, 9. So see here, this is 4. 9 is up here. So it passes through this intersection, 4, 9 right here. All right, so that's one way you could have done it. All right, so you want a line that rise 2, run 1, passing through here, rise 2, run here, rise through, run one through here. So line that you want pass through all those points. So you will want this line. I'm gonna draw it broken. To show that we don't want the line, we don't want points on the line. So this is the line. Pass through here as well. All right. So let me show you how this inequality works now. Let me show you how it works now. So I'm telling you that this inequality means that you want the region above the line up here. So me up here. All the points on this inequality are above the line. All points above the line satisfy this inequality. Yes? Look at the gradient 2 over 1. 2 is the same as 2 over 1. And gradient here, you can know the rise and know the run. Since the number is in the gradient is 2, 2 is the same as 2 over 1. So you rise 2, run 1 to go from point to point. All right. I'm going to show that this inequality here now means that you want region above the line. If you can appreciate this first part, then the rest of it might be a lot easier for you. All right. So I want any point that is in this region that I've shaded up here. Any point. Take this point, for example, right here. This point. What's the coordinate of that point? It is 2, 8. This point is 2, 8. 2, 8. That point. That point satisfies the inequality. All right? Watch this now. If I plug 2 into this equation, if I plug 2 into this equation, which is the equation of the line, if I plug 2 in this equation, when x equals 2, the y is going to be equal to 5. So there's a point on the line, 2, 5. Look at what is happening. The y value at this point up here, 2, 8. The y value is greater than 5 because 8 is greater than 5. When x equals 2 on the line, the y value is 5. See it here? 2, 5 right here. This is the point 2, 5. So for the same x value, this inequality wants a y value that is greater than 5. So you see, you want the point where the y value is greater than you would have gotten on the line. That's why you want the region above the line. Because on the line, your y is 5. Look at it, you know. On the line, your y value would have been 5. For the same x value down here, your y value would have been 5. But this inequality, I say, this inequality is basically saying, this inequality right here is basically saying, I don't want where y values are equal to 5. I want where the y values are greater than 5 for a given x value. So for this x value of 2, for example, on the line is giving me a y value of 5. The inequality here is I don't want it to be equal to 5. I want where the y values are going to be greater than 5. So it means that everywhere above the line will be valid for each x value. That's trying to explain it in a little bit of details, right? But to simplify all of that explanation, guys, you can see it, you know, on the graph, you know. The y value for the same x value of 5 above the line is greater than on the line. The y value above the line is greater than the y value on the line. On the line for x value of 2, the y value is 5. Above the line, at that point, the y value is 5 on the line. Above the line, the y value is 8. So a point up here would be valid for this inequality. But the y values in that region are greater than on the line. But don't forget into all that complicated explanation. It's quite simple. Let me show you how simple it is. It's simply this. It's simply this. This inequality this inequality, because the y over here is positive, greater than means above. So listen good enough. Greater than in an inequality generally means above, but it's when the y on the left side of the inequality is positive. The greater than means above. So this inequality simply means above. And it's a broken line. Why is it broken? Because there's no equal on the inequality. So this will be a broken line. Above the broken line. Which line? Line that is associated with this inequality. Line associated with the inequality is obtained by simply replacing the inequality sign with the equal sign. Y equals 2x plus 1. So to show this inequality on the graph, I will draw this line as I did here over here on the graph. See it here? That blue line. I will draw that line the normal way, plot 2 points or whatever. And then I will simply shade above the line. And that would take care of this inequality that I'm looking at right now. Simple as that. Simple as that. I would want the region above the line. If instead, this inequality sign right here was a less than sign, then it means that I would want below the line. So instead of above, I would now want below the line, below, if it was a less than. So I would want the region under here, below the line. I would want the region below the line under here. That's what this inequality will be indicating. I want the region below the line. If the inequality had an equal on it, if the inequality had the equal sign on it here as well, then this line, I would have to draw it solid. The solid line indicates that the line values on the line or points on the line are also valid points. So I would have to draw this line now solid. A solid line. I wouldn't draw it broken again. I would have to draw this line solid. And see, this word would change to solid. A solid line. So we can do a couple more examples of some simple lines. A couple more examples of some of the more common lines. Just a couple more examples. All right? So let me use this graph over here and do a couple more of them. And I want to see if we can put it all together on a question. All right, so let me just write a couple more inequalities and then write what they mean. All right? Because that's what it's all about. What does the inequality mean? Remember, you want the y value on the left side to be positive. Greater than means above the line, less than means below the line. When the y value on the left side is positive. So what are some examples? Let's do this one now. X plus y. Let's do this example. X plus y less than or equal to 8. Let's do that line. Want to do that inequality. X plus y less than or equal to 8. What are we looking for? The y value on the left side of the inequality is positive. So the less than means below. So we want below this line, below. We want the region that is below this line. If the line is solid or broken, because the equal is a part of the inequality, we're going to be drawing a solid line. Which line are we drawing? The one associated with this inequality is the line x plus y equals 8. And this is one of the common lines to draw. An x plus y line will cross the y-axis and x-axis at the same value. So since this is x plus y equals 8, it will cross the y-axis at 8 and cross x-axis at 8. So this line will pass through this point on the y-axis here now. Not that. This point on the y-axis here, and also pass through this point on the x-axis. Here is a common line, x plus y line. Oh, I know. Because on the y-axis, the x value is 0. So if this x value is 0, then the y equals 8. And on the y-axis, the x value is 0, and on the x-axis, the y value is 0. So the y value is 0, then the x is going to be equal to 8. So these are 2 points on that graph. This one is on the y-axis, this one is on the x-axis. It was an easy line to draw, to remember. All right? If it is x plus y equals 10, then the cross the y-axis at 10, cross the x-axis at 10. If it's x plus y equals 15, it crosses the y-axis at 15, cross the x-axis at 15. It's one of the common lines that they're going to see in linear programming. So this one, x plus y equals 8, will be this line here that I'm going to draw now. This line. See it here? Pass through 6 and 2, pass through 4 and 4, pass through 6 and 2 again. This line. That's the x plus line equals 8. X plus y equals 8 line. And then this inequality now, because the y over here is positive, the less than means below. It means that I would want the region below that line. I don't want the region under here. Simple. That's the region that I would want. Below the line. Below the line. But understand that so far? For this one, I'm doing it step by step, and then I'm going to put it all together. But online, understand that?
Sir, so why you say below the line?
Yes, sir.
Because the y over here, when the y on the left, I was just showing with points a while ago, right? Let me see if I can show an example. I don't want to get into that because I think it's going to confuse you if I try to show the points thing. But look here, simply put, if the y on the left side of the inequality is positive, less than sign means you want below the line. Can you remember that? If the y on the left-hand side of the inequality is a positive, then less than means below and greater than means above.
Oh, yes, sir.
Can you remember that? If you can remember that, you're good. You're good to go. I'm going to show you some examples, some variations. If this was a greater than sign instead, if this was instead a greater than or equal to sign, then this now will be above. Greater than means above when the left-hand side, y on the left-hand side is positive. So in that case, I would want above here. That's where I would want, above the line. In that case. All right? Let's do another simple example. Let's do another simple example. All right? I'm going to leave the less than and the below. Suppose I have the line, or the inequality x greater than or equal to 2. Or equal to 2, yeah. Suppose I want to represent this on the graph, same graph that you're looking at. The inequality, so the equation, the line associated with this inequality is the line x equals 2. The greater than means above again. So this means above. The line is solid because the equal is there. So you're going to be drawing a solid line. And the line you're drawing is x equals 2. X equals 2 is the line that is associated with that inequality. Now, how do you draw x equals 2? X equals 2, you must know, is a vertical line. X equals a number are vertical lines. So line x equals 2 is a vertical line passing through 2. If I put it on the graph over here, it will be this line. Let me take off the first one so we don't get confused. So it will be this line that I'm drawing now, this line. It will be line x equals 2. Why is that line x equals 2? Because everywhere on this line, the x value is 2. The y value is changing, but the x value is 2 everywhere on that line. Vertical lines have an equation, x equals a number. This one is x equals 2 because it passes through 2. It's vertical and passes through 2. The greater than now means that I want values of x that are greater than 2 to the right of 2. See? Over here, x value over here, for example, is 4. X value over here, for example, is 8. X value over here, for example, is 10. So this inequality means that I want the region to the right of that line. So I would want over here. Anywhere over here, I would want to the right of this line. Greater than, over there, everywhere over there, x values are greater than 2. All right? Let's do a y one now. Let's do a y1. So the next example I'm going to do now is a y1. So let's say we want to do y greater than or equal to 4. Again, we're going for greater than. Greater than means above. Because of the equal in this inequality, we're going to be drawing an unbroken solid line. The line you're drawing is the one associated with this inequality, which is y equals 4. Now, y equals 4 is a horizontal line passing through 4. You have to know that. Horizontal lines carry an equation, y equals a number. Let me take off this x equals of the diagram and put on this one now. This one. It's going to be this, so the 4 here. So the 4 right here. I need a horizontal line passing through it. So this is it. This is the line y equals 4 right here. And then I want above it. So I want above that line. So the region that I would want to be above here. Above the line. Now because of the equal in it, it means that points on the line are also valid. Points on the line are also valid. But I want points on the line and also above the line. Up here, for example, the y value is 9, greater than 4. Up here, let me take out some of these. Right here, the y value is 10. See there? It's greater than 4. Right here, the y value is 6, greater than 4. So everywhere up here, the y value is going to be greater than 4. So all these points up here will be valid. That will be my shaded region for that inequality. But I also want the line because the equal is on the inequality over here as well. All right? Let's do another one. Let's do another one. Let's do one now. Like for example, this. Let's say do an inequality. And you get this inequality. 2x plus 3y greater than or equal to 18. Let's say get that one. How do you represent that one on the graph? Pay attention now, guys. Remember, the y on the left side on inequality is positive. So the greater than means above. We have to remember that. When the y on the left side of inequality is positive, greater than means above. It's simplifying how you know whether you want above or below the line. So this means above. You want above this line. You want the region above that line. The equal is a part of the inequality, so you also want the line. So to show that you want the line, you're going to draw a solid unbroken line. A solid line. The line that you're drawing is the one associated with this inequality. All you do to get that line is replace this with an equal sign. So that line now would be the line 2x plus 3y equals 18. So I now need to draw this line on this graph and shade the region above it. So how do I draw this line on a graph? Let me put this back in red. Put this back in red. Let's put this back in red. So how do I get 2 points? I can get 2 points on this line quickly now, guys. Pay attention now. Pay attention. I'm going to put down 2 points to get it quickly. One of the points, I'm going to give it an x value of 0. The other one, I'm going to give it a y value of 0. There's a matter of working out the y value for here and the x value for here. How do I get them? It's like I take this x value of 0 and I plug it in the equation for the x. This x will be gone. I'm going to be left with 3y equals 18 when x equals 0. If 3y equals 18, 18 divided by 3 is 6. So it means that my y value is 6. For the second point, it is my y value that is 0. So I'm going to take the 0 and replace the y value here. It's like this 3y is gone because 3 times 0 is 0. So I'm left with 2x equals 18. If I have 2x equals 18, then it means that the x is 9. I divide the 18 by 2, I get 9. So when the y is 0, the x is 9. Everybody understand how I get those 2 points? You understand how I got them? People online, you understand how I got these 2 points for this graph? Students online, you understand how I got these 2 points for this graph?
Yes,
To draw this graph of this line? All right. That's a quick way to do it. Then I'm going to put down these 2 points now and then draw the graph. Now, this one is on the y-axis. 0 is the x value, 6 is the y value. That's on the y-axis. So let me show that point. Put them on in blue. So I would put the point 0, 6 right here. See? 0, 6. That's 1 point on the y-axis. Then this point is 9, 0 on the x-axis. 9, 0. So 9 out here, so this is 9. 9, 0. So I have those 2 points. I just draw a straight line through them now. And that is it. That's my line. Use a ruler and draw a straight line. And then in this case, I would want above the line. See, greater than means above. So it means that the region I want would be above this line. That would be the region line. That's the first thing, getting them one, getting one at a time. The next thing now is to combine them, put them all together. Right? So I'm going to find an example. Right? Let me look at 2018. January 2018. I think there was one where I put them all together. Internet is poor here. All right, let's go. What I'm saying, I'm looking for January 2018, right? January 2018. I think there's one on January 2018, a simple one that we can use. Illustrate the combined. Number 4. So I'll do some past paper questions now. All right, so it's a simple one here. All right, so this is a nice one to illustrate. Just a region, no inequality, no selling off anything or anything like that. Simple inequality to represent the region that satisfies these inequalities. Let's do them one at a time. So the question says we have to draw the line x plus y equals 10 and y equals x. Those are the two of the easiest lines to draw. This is an x plus y line. Remember now, lines of the form x plus y equals any number. We'll cross the y-axis at that number and cross the x-axis at that same number, like that. It's one of the easy lines to draw. So it means then that this x plus y equals 10 is going to cross the y-axis at 10 up here and also cross the x-axis at 10. That's the first one. So it's going to pass through here and pass through here. Let's do it in blue. It's going to pass through here and pass through here. X plus y equals 10. So it's going to pass through 5, 5, because 5 plus 5 is equal to 10, right? So it's going to pass through 5, 5 as well. So if you put on these 2 points and use a ruler, you can draw those two points and get the line. So it's going to go like this. That's x plus y equals 10. I must always label the line with the equal sign. X plus y equals 10. That's the first line. The next line I want us to draw is y equals x. That's an easy line again. It passes through points where the x and the y value is the same. So it passes through 0, 0, and it passes through, for example, 5, 5, and it passes through, for example, 10, 10. See, x equals y. So it's an easy line. Passes through points where the x and the y value is the same. So it will pass through right in the middle of this graph. So it pass through here, pass through here, pass through here, pass through -5, -5. All those points it will pass through. Y equals x. So it passes right down the middle of the graph. So it's gonna go like this. So excuse me, this divide doesn't allow me to draw a line straight. So that is it, all right? You use your rule and do it. Don't draw it from the line. This is y equals x. All right, that is y equals x. Then now, question said no. Look at this now. So this is the nice part of the question now. Question said we are to, on this same grid, shade the region which satisfies these 4 inequalities. So we want to shade the region which satisfies these 4 inequalities. I'm going to do it step by step. I'm going to put arrows on the diagram to indicate each one. All right. So what would this one mean? This one would mean above because of the greater than sign. So I'm going to put what each one means step by step for this one. So because of the greater above, pay attention, the y over the x over is positive, this means above. The equal is there, so we need a solid. And the line associated with this inequality is the line x equals 0. Now what you have to know is that the line x equals 0 is actually your y-axis. The y-axis is the line x equals 0. And this one is a similar thing. Y over here is positive, this greater than means above. So when above this line, because of the equal and inequality, you're going to be drawing a solid line. The line I draw and associated with this inequality is the line y equals 0. What you have to know is that the line y equals 0 is actually your x-axis. Then this line now, y over here is positive, so this less than means below. So I'm going to cross this out. This less, I'm doing for this line now. This less than means below because the y on the left side is positive. So I'm going to go below this line. And the line is solid again because the equal is a part of this inequality. So I'm going to draw a solid line. And the line that we're drawing is the line associated with this inequality, which is x plus y equals 10. But we have it already. Right? This is the line right here. This line. I'm going to put on the arrows afterwards. Then this one now is the tricker, guys. This question is the kicker. You have to be careful. First observation with this line, with this inequality, is that the y is on the right side. When it's a gradient line, not a vertical or horizontal line, a line with a positive gradient or a line with a negative gradient that can be written in the form y equals mx plus c. One of those gradient lines, positive gradient or negative gradient. Remember, guys, you want the y to be on the left side and you want it to be positive. So if you take this and just look at the inequality sign, you might believe it means above. If you just look at the inequality sign in this one, you might be thinking it means above because you might associate the greater than sign with above. But the greater than sign means above only when the y value or the y expression is on the left side of the inequality and it is positive. That is not the case. And so this greater than sign right now means below, but we can prove it because this inequality can be turned around. This inequality, it can be turned around and written as y less than or equal to x. If you read it from the right side this way, y is less than or equal to x. So you can read it this way, y is less than or equal to x. So that proves it. Because the y on the left side is now positive, and you know our less than sign. So it really means below. So instead of working with this one, better work with this one. It's the same inequality, you know. But this one could have thrown it off and caused it to go above the line. So this one now means we're working with this one. This is that I pick this question first. We're working with this one now. The less than means below. The equal is a part of the inequality. We're going to draw a solid line. The line associated with this inequality is the line y equals x. And we also have this line already. See it here, y equals x. Let's put in arrows first before we shade. So far online, everybody okay with that? All right.
Yes, sir.
All right, good. So this one first. This one means that we want values that are greater than x. So it means that we want to the right of the y-axis. We want our x values to be greater than 0, I should say. So you want values to the right of the y-axis. To the right of the y-axis, your x values are greater than 0. So I'm going to put the arrow pointing to the right of the y-axis. That's the first one. So the region that I want is somewhere over here, but I'm not going to shade. Then for this one, I want values above my x-axis because I want where y values are greater than 0. See? Y values must be greater than 0. I want above the x-axis. So see the x-axis here, I'm going to put the arrow pointing up. So right now, my final region is somewhere in this quadrant now. But I'm not going to shade it. I'm going to narrow it down. The third inequality is this one. I want below the line x plus y equals 10. See the line where x plus y equals 10 here? This inequality is telling me that I want below it. So I want under here, somewhere below this line. Below that line, x plus y equals 10. So I'm going to put the arrow pointing down for that one to remind me that I want below this line. Put the arrow pointing down. And then for the last one, I want below y equals x. So line y equals x here. I want below it. Below it. So I'm going to put the arrow pointing down to remind me that I want below this line. I'm going to put them all together now. I want below this line that I just did. Below this one. I want below this one as well. Below. So arrow pointing down here. Below this one. And I want above the x-axis. See the arrow there? Above the x-axis. I also want to the right of this y-axis, you know, but this kind of cut it off. So it don't matter. So the region that I want is inside here. That satisfies all three. Satisfy all of them inside here. That is the region that I want. Right there. Satisfy all inequalities. That's the shaded region. But understand that? Online, you understand that? Yes. So plenty people would have read this as above and would have gone and shaded here. They would have read it as above this line, this one. Right? But that would be wrong. All right? So that is that. Let us see if we can do another example. All right? Let's look at 2021 question 4B. Trying to find some simple ones first. 2021 4B. 2021 4B. Just remember, guys. You want when you have the inequalities and you're getting the lines, you want the y value to be on the left side and positive. You want the y values to be on the left side and positive. When you have that, greater than means above, less than means below. It's as simple as that. You understand that, what I just said? So for example, if I give you this, let me tell you what I mean. Let me show you. Let me give you an example. if I have 2x plus 3y less than or equal to 5, it means that I want below this line because the y over here is positive. So this means below. I want below this line. But what if I now change this y value right here? I make it negative. Negative, that don't mean below anymore. It now means above. Why is it above? Because I can take this negative 3y greater than 2x and cover this 5 minus 5. You can turn around, this whole thing can be spun around until I made 3y. Y so that gymnastics of going from this to this to show that it means above. Just look out for this. You look where the y value is, and you want the y value on the left side of the inequality to be positive. Once the y value on the left side of the inequality is positive, less than means below, greater than means above. Greater than means above. That is all. When the y value on the left side of the inequality is positive. When the y value on the left side of the inequality is positive, greater than means below, less than means above. Anything apart from that, less than, don't mean above. In all. We don't have to get into the gymnastics of switching it to show you to prove it. All right, let's look at another example. 4B on this paper. All right, so one here. Here's another one. This is another one. I'm doing the simple ones first, and then we're gonna do the linear programming one. So I'm cross them off as I do them. So another 4B. And this was a 4B. All right, let's do this one now. So this question says, use a ruler to draw these lines. X equals a half, y equals x, x plus y equals 5. Easy lines to draw. So x equals a half, remember it's going to be a vertical line passing through half. Remember the x equals a number, just remember the y-axis is x equals 0. So x equals a number, any number is going to be vertical like the y-axis. And remember that the x-axis down here is the line y equals 0. So y equals a number is going to be horizontal like the x-axis. Easy to remember these things, guys. All right? So let's continue now. So we're drawing this line for x equals half. It's a vertical line passing through half. So 1 here, so this must be half. So x equals half is a vertical line passing through here. So this line number 1, this line. Use a ruler and draw it, guys. Don't draw it to the front like me. Just that I can draw a straight line with this device. This is the line x equals half. I'm going to extend it all the way up here. X equals a half. Next line to draw is y equals x, an easy line. I'm going to stop talking now. Stop talking now, man. X equals y equals x. That line is another easy line. Passes through points where the x and the y are the same. That common line. So it passes through 0, 0, 1, 1, 2, 2, and so on, right? Usually pass right down the middle of the graph when x and y axis scale are the same. So it pass through 0, 0, it pass through 1, 1, pass through 2, 2, and so on. So it will go right down the middle of your graph like this. Use a ruler and draw it. Don't draw it friendly like me. All right, y equals x is this line. Label the line y equals x. That is it. Y equals x. The next line is another easy line. X plus y equals 5. Common number, x plus y line. Crosses the y-axis at 5 and crosses the x-axis at 5. So that line, this one, will cross the y-axis at 5 up here and also cross the x-axis at 5 down here. All right? So it passes through here and passes through here. All right? So it will pass through 1, 4 as well, because x plus y equals 5, 2, 3, because x plus y equals 5. To pass through 2.5, 2.5 here, pass through 3, 2, pass through 4, 1, pass through all those points. But you could just use a ruler, connect these 2 points and draw it. All right? So let's draw it down here now. This is the line x plus y equals 5. I'm going to label it. X plus y equals 5. X plus y equals 5. All right? What they want us to do now? Then they want us to show some inequalities on it now. Let's do them one at a time. They want us now to see there on the grid, label as R, region width, the region where x is greater than a half, y is greater than x plus y is less than 5. Let's do them one at a time. This one first. The greater than here means above. So remember, x equals a half is a vertical line, you know. This means that you're going to the right of that line. X plus y equals x equals a half. You're going to the right of x equals a half. Because I want where the x values are greater than a half. So you're going to the right of that line. See the line x equals a half here? This one. That's the first line that we drew. We're going to the right of that line. So I'm going to put the arrow pointing to the right for the first inequality. Then this one next. This one next. Y greater than or equal to x. So y over here is positive. So the greater than means above. So when above this line, above the line y equals x. So line y equals x here, this line. We're going above it. So I'm going to put up arrow pointing up. So far the region I want is inside here now. Somewhere in here. That's the region that we want so far. Above y equals x and to the right of that vertical line. That's the region that we want so far. But we're not done yet. We have one more to put in. So take that off. So we need to put in the last inequality now. This one. X plus y less than or equal to 5. The y on the left side is positive. Good. The less than therefore means below. The y on the left side of this inequality is positive. So the less than means that we're going below the line. So this means that we're going below the line x plus y equals 5. Because x plus y equals 5 is the line associated with that inequality. We're going below it. Line x plus y equals 5 is this line here, this one. This one. We're going below it. So we're going below this line, below this one. So you must see the region that we want to know. Below this one, above this one. See here, above this one. To the right of this one. To the right of that one. The R is supposed to be inside here. That's where they want. So label it with an R, right? See? Label with an R. That is the region that satisfies the 3 inequalities. Right here. That's where the R is supposed to be. If they told us to shade it, we would have shaded in here. That's where we would have shaded if they told us to shade it. But this time I'm going to label it with an R. I'm not just putting an R there. But okay with that? Online,
Yes,
but okay with that?
Sir, I think you can zoom up, become more, you can screenshot it.
Huh? I mean this way?
Yes, sir.
All right, good. All right, so I'll do some simple ones so far. I could put some sugar on it now. Right? Gonna put some sugar on it now. All right, there might be another spell. 8A, 2021, 2019, 8B, 2022, 8. All right. I think 2022 number 8 is a full question. I'm not going to do that one yet. All right, let's do 2016 9A. Let's do 2016 9A. We have about a 45 minutes also to go. Let's do as many as we can in the time, at least 3. Let's see if we can finish 3 of them. 2016, January 2016, 9A. January 2016. 2016. 2016 9A. All right, another easy one, listen. All right, it's another easy one, this. Now that I want to hear, skip over that one. That one is too easy. Let's do 2019 8B. I'll come back to that one. 2019 8B. 2019. One to one now. Have some linear programming in it. All right. 2019 8B. Where are we? 2019 8B. What is one easy to? Nah, not that one there. Want to do a nice one now, guys. I don't want to do them simple one. I want to do a nice one. All right, let's look at 2022, 2021 8A. We can come back to those if necessary, but I want to do a nice one. 2021 8A. $21 8A. Let me say. It's not right. I picked the wrong one. Nah. It's 8B. I'm supposed to say. The wrong paper. I wrote down the wrong paper. I was July. No, July. July. It's July. All right, this question. Let's do this question. Yeah, man. See a real question here now. This question, they mess up the graph. So I'm just going to rescale the graph and do it. They kind of mess up the graph, guys, because CSEC do this sometimes. They make mistakes sometimes on the paper. So they mess up the graph by putting 1, 2, 3, and I put 5 here. Should have been 4, right? And then up here, they went 1, 2, 3, 4, 5. So they messed up the scale on this paper. So I'm going to rescale it. Well, let's do the question first. Let's do the material part of the question first. Let's go. This question says, Marla buys 2 types of mobile phones, B Flow and C Flex. Let's just call them B and C for simplicity, B and C. From a company to retail. It says one B phone is for $60, while a C phone is for $80. All right, let's make a note of that. So the B phones is for $60 each, while the C phone is for $80 each. All right. It says she buys X number of B phones. So she buy X of these phones, you know, the number of phones that she buy here, so is X. She buy X of them. And she buy Y C phones. So the number of C phones she buying is Y. Remember, you don't know X and you don't know Y, you know? You don't know those values. You don't know actually how many phones you buy. But X represents the number of B phones. Y represents the number of C phones. Watch this now. Marla must not spend more than $1,200. Marla must not spend more than $1,200. Means that the total amount that she spends must be $1,200 or less. Remember that the amount that she's spending, you know, is $60 times X phones plus $80 times Y of the other phones. That's the total amount that she's spending. It has to be less than or equal to 1,200. She must not spend more than 1,200. Another way to say this is that Marla only has $1,200 to spend. She can't spend more than she has. Good? So the total that she spends is $60 times X, because it's X phones, $60 each. That's the first on the B phones. So she's spending $60 times X. I don't have to put the dollar sign. Plus, she's spending $80 times Y. Y phones at $80 each. That's 80 times Y. That's the total amount that she's spending now. That amount that she spends has to be less than or equal to 1,200. I can put the dollar sign on it, but that they will cancel off, so I don't need to put the dollar signs on it. Everybody understand that inequality so far? Online? And close the door for me, because people not no more marathon. Everybody understand this so far?
Yes, sir.
Online. Everybody understand this online?
Yes, sir.
Yes,
All
sir.
right, good. And you want to simplify it, right? You must simplify it. This can be divided through by what? By 20. You can divide each of these by 20. I can divide out the zeros first, and then divide through by 2. So you can divide through by 20, right? To simplify it. Simplify the inequality down to lowest terms. So I'm going to divide through by 20. If I divide this by 20, I'm going to get 3x. Divide this by 20, I'm going to get 4y. Divide this by 20, so I'm going to get 60. But I go to that. That is the first inequality. I must always simplify down to lowest terms. That's the first inequality. Next part says, the number of B phones. Remember, the number of B phones is X now. See, the number of B phones. Remember, it is X B phones. The number of B phones must be greater than or equal to, see, greater than or equal to the number of C phones. The number of C phones is Y. Write an inequality to represent this information. They tell you straight, the number of B phones, which is X, must be greater than or equal to, see, greater than or equal to the number of C phones. C phones is Y. That's inequality, you know. X must be greater than or equal to Y. But remember, we don't like the Y to be on the right side. So we spin it around and read it instead as Y less than or equal to x. So this less than now is going to mean below. So we're not working with this one because the greater than might cause us to think it is above. But the y needs to be on the left side and positive, and now that it is less than, it means below. But understand this? Online? But understand this? So I'm going to be working with this inequality. I want the y to be on the left side. I want it to be positive. I'll come up with a simple way to read inequalities. Greater than means above when the y on the left side is positive. Less than means below when the y on the left side is positive. This one, the y was on the right side, so the greater than don't mean above anymore. It actually means below. This shows it. Because when I spin it around, I end up with a less than sign, which means below. Get me? Good. Because we have to put this on a graph now. Next one. It says represent the two inequalities on the grid and label R the region which satisfies the two inequalities. So this one is pretty easy. So the two inequalities we need to put. Let's write what each of them means first. Let's write what they mean first and how we're going to plot them. So this one first. The y on the left side is positive, less than means below. Don't put it, can't put it below, can't put it under here. In red. So the y over here is positive, so the less than means below. The y is on the left side of the inequality and it is positive. So this less than sign means below, guys. Below. The inequality has the equal on it. So we're going to be drawing a solid line, not a broken line. If the equal is not there, you'd have to draw a broken line. So we're going to be drawing an unbroken or a solid line. And the line that we're drawing is a line associated with this inequality. That line is obtained by just changing this and put the equal. So that line is 3x plus 4y equals 60. So we need to draw this line now. So we need 2 points on it. Let me show you can get 2 points on it to draw it quickly. We don't need to do no big long thing to draw this line quickly. 2 points on it. One of them, I'm going to put a 0 on the x-axis, on the y-axis, sorry. And the other one, I'm going to put a y value of 0 on the x-axis. And then I'm going to use the equation to work out the value for here and the value for there. Watch it now. For this one, where the x value is 0, this will be gone if you put the 0 there. Because 3 times 0 is 0. I will be left with 4y equals 60. If 4 equals 60, you divide by the 4, you get 15. So the y value is 15. So this point where the x value is 0, the y value is 15. That's a quick way to find a point. For this other point, I am putting the y value here equals 0 now. If the y value equals 0, like the y value gone, I'm left with 3x equals 60. If 3x equals 60, then the x equals 20. So it means that that other point will be 20, 0. So that is how I have found 2 points that's going to be on this line quickly. 1 point is 0, 15 on the y-axis, 20, 0 on the x-axis. Easy as that. And then this line is an easy line to draw. It's a y equals x line. The less than means below because the y over here is positive, so we're going below this line. The equal is there, so we're drawing a solid line. And the line we're drawing is line y equals x, which is an easy line. Now these things in the red, you don't have to put on the exam paper. Well, you might need to work out these 2 points, but you don't have to write this part. You have to know that you're going below the line. You don't need to write this. Similarly, you don't need to write this, but you have to know that you're going below the line. If I'm in the exam, I'm writing it, so I don't forget. All right? So anyway, we're going to draw those 2 lines now. Let's do this one up here first. Remember I said I'm going to change the scale of the graph, right? Because CSEC messed up the scales. So I'm going to make every centimeter 2. So I'm going to take out these original markings that they have. Take out these markings that they have. So I'm taking out these markings that they gave. I'm not going to use them. Right? And if you realize in the exam room that scale is messed up, guys, you can do this. You can do this as well. Don't be afraid. Huh? The scale messed up, man. You see, it's 4 lines. Look. 1, 2, 3, and I put 5 right there. So. And there's inconsistency because up here now, you have 1, 2, 3, 4, 5. You see that? So the scale up here is different from on the x-axis. So you can't work with these values. So I'm taking them out. So I'm removing these guys. I'm removing these. I'm putting in my own scale. All right, on this graph. Scale was messed up. It happens. CSEC make mistakes sometimes with the papers. They're human beings as well. All right, so let's put in our own scale. All right, and what I'm going to do to ensure that the 50, the 20, and so on fit on the graph, I'm going to make each centimeter be 2. So it's going to be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. I'm putting 20 right there. 1 centimeter to 2. That's what I'm going to do. Same thing up here. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. I'm going to use that as my scale right there. Keep it simple. So the first line, remember, is this line, 0, 15, and 20, 0. That's where it passed through. 0, 15, and 20, 0. So 0, 15 first on the y-axis. So 0, 15. So come up on the y-axis to 15. So all right. So this is 14 right here. Look, note now, guys. This is 14. Let's draw the graph in purple. Or in red. So 15 will be right halfway between the 14 and the 16 right here. Right here. Will be the 15. 0, 15. And then 20, 0 will be right here. Right here is 20, 0. So you need a straight line now passing through those 2 points. Use a ruler and draw a straight line through those 2 points. I'm just going to draw my best straight line that I can miss. Something like that. But you need to use a ruler and draw it, right? All right, let's work with that. So I'm saying that this line is, what's the first line again? First line is 3x plus 4y equals 60. 3x plus 4y equals 60. 3x plus 4y equals 60. I want below that line or above it. I don't remember. I want it below that line. Below. So I'm going to put the arrow pointing down to mean that I want below. So right now the region that I want is below this line. The next line we're drawing is this line. Y equals x, and we also want below that line. Y equals x. So that line is an easy line to draw. It passes through 0, 0. It's going to pass through 4, 4 right here. Pass through 8, 8 right there, and so on, right? So you go right down the middle of a graph. Y equals x. Like that. Draw it to the ruler, guys. Don't draw it friendly like me. Y equals x. I also want below this line. So I want below the 2 lines. You're going to automatically want above this line, you know. Because remember, you know, you're buying more than 0 phones. The number of phones is going to be greater than 0, right? So you're automatically going to be above this line and to the right of this line. Because you're buying more than 0 phones. What I'm supposed to do? Label as R. Label R. So the region that you want is right inside here. But okay with that? But all right?
Yes, sir. Yes, sir.
All right. So that was, I don't want us to do anything else. See, they want us to do anything else. All right. Yes, they want us to do something else. All right. This says the total number of mobile phones represented by X plus Y. Here. It says, according to the graph on page 21, what is the largest possible value of X plus Y? To get the largest possible value of X plus Y, you have to go to the vertices. You want the largest value of any function relating to the graph, you go to the vertices. You go and look at the vertices. And you want the vertex where the X plus Y is greatest. All right? Remember also that you can't have a fraction number of phones. It's a whole number of values of phones you can have. So you go to the vertices. I think for this one, it was right here. But right here we have 20 phones. Right here, X plus Y equals 20 right there. Now, that point is 20, 0. So X plus Y right there says 20, right? Right there says 20. Watch this now. Look at this verse. This is 0, 0, right? So remember, you're investigating the 3 vertices, you know, which one of them the X plus Y is greater. Right here, so X plus Y is 20. Agreed? Right here. X plus Y is 0 right here. That's clearly out of it. So this is the other point to investigate now. That other vertex. But right here, if you look at it, it's actually below 10, 10. Because on this line where Y equals X, you know, and 10, 10 would have been right here. So on this line, and 10, 10 would have been right here. Look at it good enough. Right here is 10, 10. Right here is 10, 10. That point is 10, 10. But that point is outside the region. See it? See that? So this point right here, the other vertex, whatever the number of phones is, the X is going to be less than 10 and the Y is going to be less than 10. So there's no way X plus Y here can be greater than 20. But understand that? But understand that? Because at this point right here, the X value is going to be less than 10 and the Y value is going to be less than 10. Because 10, 10 is right here on this line. 10, 10. On this line is 10, 10. This point is the vertex of the region. This point is not valid. You can't use this point because it is outside the region. The region is inside here. You can only use points inside here or on the lines bounding this region. This region that I'm marking out is blue is the only places where you can have a number of phones to satisfy the conditions. This point is outside that region, but that is where X plus Y will be equal to 20 as large as here. So it is obvious that this other vertex here, the X plus Y is going to be less than 20. Here is where you're getting the most. Right? So this is the point 20, 0. So it's at the point 20, 0. Where you're getting the maximum value of X plus Y. That is when you have 20 B phones and 0 C phones. So that's where you have to operate for X plus Y to be maximum, largest possible value on this question. And it's done. All right, let's do another one. I think there was a nice one. There's a nice one for Groom Conquer 21. There's a nice one on 2022. Let's look at 2022. I want to do 2 more before we finish. June 2022. Let's see. June 2022. Number 8. All right, there you go. Here's a nice question. Let's do this one. This is a full June 2022, they set a full linear programming question, full one. All right, let's do this one. Let me finish off with this one. All right, so pay attention, everybody. Let's finish off with this one. This is a full one. This question says, a rental company has X cars and Y minivans. We're just going to say Y vans. Keep it simple, right? So X is the number of cars and Y is the number of vans. Remember, you don't know X and you don't know Y. It says it has at least 8 vehicles. Now, the word vehicle is taken to mean the sum or the total of the cars and the vans. That's X plus Y. At least 8 means 8 or more. If you must have at least $8 to do something, it means that you need 8 or more dollars. So the number of vehicles, which is the cars and the vans added up together, must be at least 8, meaning greater than or equal to 8. So this inequality that we're getting from this condition, and I want us to write 3 inequalities from this whole statement. 3 inequalities. This first one means that X plus Y is greater than or equal to 8. Because I said this number of vehicles, which is the sum of the vans and the cars, must be at least 8 or more. So oftentimes with this topic, they give you one word to mean the sum of the thing that they're talking about. So if you have a question talking about fruits, apples and bananas, and they have X apples and Y bananas, there might be a statement that says the number of fruits must be no more than 10, which would mean that X plus Y must be less than or equal to 10, because the fruits now be taken to mean the sum of the apples and the bananas. So oftentimes they'll use a one word to mean the sum of the thing that they're talking about. In this case, it is vehicles. That's X plus Y. Number of cars plus the number of vans must be at least 8, means 8 or more. It says the number of minivans, which is Y, must be less than or equal to the number of cars. See? The number of minivans, which is Y, must be less than or equal to, see there, less than or equal to the number of cars, which is X. That's another inequality that just gave us straight. Y must be less than or equal to X. That's the second one. Then it gave us another one. There must be no more than 9 cars. See, the number of cars must be no more than 9. The number of cars, which is X, must be no more than 9, meaning it can be 9 or less. So the number of cars, which is X, must be less than or equal to 9. Can't be more than 9. No more than 9 means 9 or less. So this is the third inequality. Try them that, that I've written out for you. Try them that. Each statement giving us one. Let's write them out here. So the first one is X plus Y must be greater than or equal to 8. The second one is that Y must be less than or equal to X. And the third one is that X must be less than or equal to 9. The X must be less than or equal to 9. That's the third inequality. But go to that online. Online, everybody okay with that?
Yes, sir.
Yes, sir.
Yes, sir.
All right, good. The next part now says a car can carry 4 persons. Remember, there are X cars, you know. So right away, if there are X cars and each car is carrying 4 persons, the total persons in the cars is 4X. You have to be mindful of that. So you have 4X persons right here, 4X people. 4 persons in each car. Remember, there are X cars. So the total number of persons in the cars is 4 times X. Then the number of vans, a minivan can carry 6 persons. Remember, there are Y minivans. And each minivan is carrying 6 persons. So the total persons in the minivans right away is going to be 6 times Y. You have to recognize these things. 6 times Y. So this is total number of persons in cars. That's the total number of persons in minivans. 6 persons per minivan, there are Y minivans. So the total in the minivans is 6 times Y. 4 persons per car, there are X cars. So the total number of persons in the cars is 4 times X. So this total represents the total number of persons altogether. 4X plus 6Y. But let's continue. It says, there are at most 60 persons to be taken on a tour. At most. At most means 60 is the highest. The total number of persons has to be 60 or less, because 60 is the most. So the total number of persons must be 60 or less. So this now we're going to add up, if we get the total number of persons in the cars plus in the vans, that total number of persons must be less than or equal to 60, because 60 is the most you can have. So this is the inequality for that information. And the question says, show that 2x plus 3y is less than or equal to 30. All I have to do is divide this by 2. I will get this. Divide this by 2. I will get this. So this is a statement. It's an information that they gave us. This is what I would write first. But to get this final thing, we divide 2 by 2. So I'm going to divide this inequality by 2. And it's going to become that. So we're going to get it. 2x plus 3y less than or equal to 30. That is it. So that was shown. We're going to have to plot all these inequalities on a graph. That's what it is all the time. All right? So ready now. This question says, on the grid below, plot the 4 lines associated with the inequalities, and then we must shade and label the region R. Shade and label the region which satisfies all inequalities R. Must shade it and label it R. All right, so we need to draw those 4 lines now. So ready now. Let's analyze them one at a time and see what we're going to draw. Let's break it down. So this one first. The y over here is positive, greater than means above. So for this one, we're going above. Well, first, all the lines are solid, right? Equal is there, equal is there, equal is there. Even the one down here, the equal is there. So we know that all the lines are solid. So we can write that from now. All solid lines. We're going to be drawing all 4 lines solid. All right, come again. The y over here is positive on the left side, so greater than means above. So for the first one, we're going above. Which line? The line x plus y equals 8. That's an easy line. Crosses the y-axis at 8, crosses the x-axis at 8. It's an x plus y line. Then this one now is another easy line. The y over here is positive, the less than means below. So we're going below this line. Which line we're going below? Y equals x. Another easy line to draw. Passes through the points where the x and the y values are the same. So it passes through 0, 0, 1, 1, 2, 2, and so on. Below y equals x. Then this one now, the x over here is positive. The less than means below. That's just our x equals the line. We're going below. So we're going below the line x equals 9. That's a vertical line, you know. Below a vertical line means that we want to the left of the line. Means that we want to the left of the line, x equals 9. So less than means below on this line means that we want to the left of the line, x equals 9. That's what this below means on a vertical line. Above on a vertical line means that you want to the right. Below on a vertical line means that you want to the left. All right, x equals 9 is a vertical line passing through 9. All right, this below means that you want values that are less than 9. So you're coming to the left of that vertical line. Then this one down here now, we're going to need 2 points on it as usual. All right. So firstly, the y value over here is positive. The less than means below. So now we're going below this line as well. The line is solid. We said that already. We need 2 points. I'm going to set it up to draw 2 points like this again. The first point, we're going to give it an x value of 0. The second point, we're going to give it a y value of 0. For the first point, we're going to give it an x value of 0. This is going to be gone when I put the 0. I'm going to, let me put the line. Sorry, I need to put the line. I need to put the line. Sorry, I need to put the line. The line Tom John didn't put the line yet. So I'm going below the line, 2x plus 3y equals 30. This is a line that is associated with this inequality. Then we're going to do the 2 points thing here now. Let's do it here. One of the x value of 0, get the other one a y value of 0. Ready now. When I plug the 0 for the x value here, the 2x will be gone. I believe with 3y equals 30. If 3y equals 30, divided by 3, you're going to get the y value equals 10. So when the x is 0, the y equals 10. That's a quick way to get it. For the second one, I'm going to put the y value equals 0 right here. That's going to eliminate the 3y. I'm going to be left with 2x equals 30. If 2x equals 30 divided by the 2, you're going to get 15. X equals 15. So I'm going to get 15, 0. So these are 2 points that are on this line. This point is on the y-axis, 0, 10. This point on the x-axis, 15, 0 on the x-axis. So I now have everything I need to draw those 4 lines on the graph. Let's do them one at a time. First one is above x plus y equals 8. X plus y equals 8. Now, x plus y equals 8 passes through 8 on the y-axis and on the x-axis. X plus y equals 8. So it passes through here and here. So we're drawing the line passing through these 2 points. Also pass through 4, 4, x plus y equals 8. Pass through 2, 6. Pass through 6, 2. X plus y equals 8 at all those points. Pass through 1, 7. 1 and 7 is 8. Pass through 7, 1. 7, 1 is 8. See it? So you pass through all those points. But all you would need originally are these 2 points. Use a ruler. You don't need all these points in here. I'm just doing it because I don't have a ruler. I can't draw a straight line on this device. Get me? Well, you just need these 2 points. Use a ruler and draw it. All right? So I'm going to draw the line now. Label the line with the equals sign. X plus y equals 8. What did we say? Above that line or below? Above, right? Above. Because it's above, I'm not going to shade it. I'm just going to put the arrow pointing up, down here. Put the arrow pointing up. It means that the region that I want is somewhere above this line. So I'm not going to shade as yet. Second line is this one, y equals x, and I need to go below it, y equals x. So y equals x is an easy line, as we said, pass through 0, 0. It's going to pass through 4, 4, for example, right here is 4, 4. So it's going to go right down the middle of the graph like this. One of the easiest lines to draw, y equals x, if not the easiest. Label the line with the equals sign, y equals x. And what below that line? Let me see. Below that line. So I put the arrow below it. Put the arrow pointing down. Means that I want below that line. Let me see if I can make this a little brighter. All right, so the region that I want so far is up here. No, sorry. Above this one and below this one. So the region that I want so far is somewhere over here. All right, but I'm not finished yet. Let's continue. Let's put in the next one. The next one is x equals 9. I want below that line. Below a vertical line means you want to the left of the vertical line. So x equals 9 is a vertical line through 9. It's 9 right here, so. It's 9 here, so. I want a vertical line through it. So that vertical line is this one up here, so vertical line. Vertical line passing through 9. It's 9 here, x equals 9. Let's get all the way up. This is the line x equals 9. I want the region to the left of it. So right now, the region that I want is somewhere inside here. I'm narrowing down the region enough. I still have one more inequality to draw, right? Which one is that? Which is this one. Drawing this line. I will say the pass through 0, 10 on the y-axis, 15, 0 on the x-axis. I'm drawing this line. I want below that one. 0, 10 on the y-axis, it up here. 0, 10 up here. And 15, 0. 15, 0 is down here. All right? So I need a line now through these 2 points. One straight line through those 2 points. Let me see if I can figure out a couple of points where it passes, because as I said, I can't draw it with my free hand. So looks like it passed through here. That's right. Let me see. No. Looks like it passed through here. And looks like it passed through there. Yeah, those 2 points. So use a roll and draw it. That will be the line. All right, that is it. And that line is, what is it again? 2x plus 3y equals 30. 2x plus 3y equals 30 is this line. You draw it with a ruler. Do not draw it freehand like me. And we want below that line, right? Below that line. So look at it now. Let me draw it in blue. We want below this line. We want below this one as well, which is under here. We want it above this one, which is up here. And to the left of this vertical one here. So you can see that the region that we want is inside here. Then we must label it and shade it. So this is the region that we want, satisfying all of the 4 inequalities. Let's shade it in green here. And so label it and shade it. I don't understand. I'm going to ask you to do one of the things. That's the region that we want. And this little line is a part of it as well, right here. Remember now, you're greater than number of cars and number of vans will be greater than 0 as well. So above this is also good. So this is a part of the region. This is the horizontal piece right there. But that is the region right there. I have labeled it R. But I go to that so far?
Yes, sir. Yes, sir.
All right, good. Now, what else I want us to do? So I've drawn the graph, and then I'm going to ask us some questions about the graph now. This question says, determine 2 combinations for the minimum number of cars and vans that can be used to carry exactly 60 people on the tour. Remember, to carry 60 people on the tour, guys, watch this now. To carry 60 people on the tour relates to this inequality. That inequality was about carrying 60 people on the tour. So if we're going to carry exactly 60 people on the tour, then this inequality is going to now become equal. You get me? Because you're carrying exactly 60 people. They never say carry a maximum of 60 now. If you carry exactly 60 people, then 4x plus 6y will now have to be equal to 60. And then it's going to then now again be related to this inequality, because we're going to then divide it by 2. And then we put equal 30 here, so it means that you're talking about this line. So to carry exactly 60 people, guys, they're going to be on this line. You understand that? Because if you carry exactly 60 people, this inequality would instead become 4x plus 6y equals 60. If you divide 2 by 2, it would then become 2x plus 3y equals 30. So to carry exactly 60 people, you need to be on this line. You get me? So the points that they want are on that line. And you have to go to the vertices to determine the maximum and minimum of anything in these things. So you're going on this line and you're going to the vertices of the region on this line to carry exactly 60 people to see what the combination is. Let's go for the line now. So see here we're talking about this line. What are the vertices on the region for that line? The vertices on this line is right here and right here. So those are the 2 points where you want to be able to carry 60 people. This point is a point 9, 4. It's one combination, 9, 4, which means 9 cars and 4 vans. Number X is the number of cars, Y is the number of vans. Also, you can go and operate here. To carry 60 people, you can also go here. You could use 6, 6. That's a point 6, 6. See there? 6, 6. 6, 6 is a point. So this is a point 6, 6. So meaning, to carry exactly 60 persons, you could use 6 cars and 6 vans. We can check it now. To carry exactly 60 persons, we're either going to use this combination or this combination. Let's test them. Let's test them here. So we're using 6, 6. Meaning 6 cars and 6 vans. The number of persons will be equal to 6 cars times 4 persons. See, that's 6 times 4 plus 6 vans times 6 persons per van. Remember? 6 times 6. This will work out to be 24 plus 36. That will be equal to 60 persons. See that? So 6 cars and 6 vans will carry exactly 60 persons. Let's test this point as well. 9, 4. So if you're using 9, 4, which means 9 cars and 4 vans. 9 cars and 4 vans. Then the number of persons on this store. We're kind of double checking. This calculation is not necessary, guys. I'm just checking if those points are correct. So I would carry 9, remember it's 9 cars and it's 4 persons per car. So it's 9 times 4 persons. 9 cars, 4 persons. Plus 4 vans. Remember, each van is carrying 6 persons. So it's 4 vans by 6 persons. This is 36. And this is 24. Again, this adds up to 60 persons. So these are actually the 2 combinations that can carry exactly 60 persons. But I said that. So you go on the line that was related to carrying 60 persons. Because you want to carry exactly 60 persons, you make it equal, meaning that you're on the line. Because it's not equal, you're on the line. And if you want to find maximum or minimum of anything in this topic, you go to the vertices. Just remember that. Go to the vertices of the common region, or of the shaded region, of the wanted region. So that's why I went to the vertices along this line. This line was the line for carrying 60 persons exactly. All right? So that is the answer. 6, 6, and 9, 4. See? Determine the 2 combinations for the minimum number of cars and minivans that can be used to carry exactly 60 persons. So it's 6, 6 and 9, 4. 6, 6 means 6 cars and 6 vans. And the 9, 4 means 9 cars and 4 vans. That's why the vans instead of minivans. So those are the 2 combinations that can carry 60 persons. All right? And the next part down here now says, the company charges $75 to rent a car. Remember, there are X cars, and they're paying $75 for each. So the money for renting cars is going to be $75 times X. That's right here. 75 times X to rent the cars. And they're paying $90 for a minivan. I remember there were Y minivans. So the money for rent the minivans is going to be $90 times Y. So the money for renting the cars is $75 times X, because they're X cars. And for renting the vans is $90 times Y, because they were Y vans. And it's $90 for one. So the total money to rent becomes $75 times X. Let's write this better. Plus $90 times Y. That's the total money to rent the vehicles to go on the tour. It says show that the minimum rental for the tour is $990. The minimum rental for the tour is $990. So you basically want to see how much these gonna cost you. When you rent 6 vans and 6 cars, what's that gonna cost you? And when you rent 9 cars and 4 vans, what that's gonna cost you. Remember, these are the 2 combinations that can carry exactly 60 persons on that tour now. So you want to see what the cost is gonna be for this combination, what's it gonna be for this combination, and see which one is the cheaper one. The cheaper one is gonna be the $990. So let's work it out. But this is the money for the rental fee. This is the total rental fee. I just call it T. So let's test this for 6.6. So for 6.6, the total is going to be $75 times 6 plus $90 times 6. Work that out for me. And for the 9.4, the total is going to be $75 times 9, because the X equals 9 this time, plus $90 times 4, because the Y equals 4 this time. We need to work those out and see which one of them is 990. See what they work out. Let me divide the screen and work it out. Huh? First one get 990. So you get 990 for this. So this one works out to be $990. This one works out to be what? 1,035. So you see, this one is a cheaper option. This one is a cheaper one. This one is a cheaper one. See, that's the minimum. So to go on the tour and carry the same 60 persons, is it better to use 6 cars and 6 vans rather than 9 cars and 4 vans? Because if you spend less money, pay 990. That's why 990 is the minimum. So therefore shown that the 990 is the minimum. So this is the minimum amount that will carry them. And that is right on 9 o'clock. Yeah, but that is it. Online, everybody okay? The paper, first paper, the Sunday paper. Huh? Oh, look at the thing there. Tomorrow we're doing, I don't remember the topic that we're doing tomorrow. At 4 o'clock. So we have another session tomorrow to go through 2 more topics. Let me see what the topics are. What are the topics that we're doing tomorrow? Let me see. We said we are going to do tomorrow. We said we're going to do elevation and solid geometry. Elevation and depression and solid geometry. I put in a couple other things as well. So these are 2 easy things. Elevation and depression and solid geometry. Huh? Huh? I like what? Functions? Inverse functions? We see. All right, online. Bye. See you tomorrow. Another session tomorrow evening.
Guys, have a good night. Bye.
All right. Okay. Bye-bye.
Bye.
Okay. Bye-bye. All right. Bye, everybody. Is that Nai from Tobago? Nai?